Hello there, and welcome where curiosity takes a deep breath and drifts slowly into the mysteries that most of us only glimpse in dreams. Tonight's quiet dive is one that doesn't need a passport or a wetsuit, only a bit of imagination and a willingness to sink gently into the unknown. You see, there's a place on Earth so deep and so remote that light itself gives up before reaching the bottom. It's called the Mariana Trench. A scar in the ocean floor deeper than the tallest mountain is high. A world of darkness, silence and crushing pressure hidden beneath the calm surface of the Pacific. Before we descend into that silence, I'd love to know, where are you listening from tonight? Are you somewhere near the ocean, where the rhythm of waves hums in the distance? Or are you landlocked, where the sea exists only as a sound in your mind? And if you close your eyes for a moment, can you picture it? The surface of the water, the shimmer of moonlight, the thought that beneath that glow lies a darkness so deep that no sunlight has ever touched it. If you find these slow wanderings through science and wonder soothing, perhaps leave a like or even subscribe. It helps this quiet corner reach a few more sleepless thinkers like you. Now, let's take that first breath and begin our descent. Because somewhere beneath all that blue lies a story not of monsters or lost ships, but of limits. The limits of pressure, of technology, of the human mind, and of curiosity itself. Imagine standing on the shore looking out at the ocean. The waves seem endless, stretching past the horizon, but what we see is only a fraction of it. The Mariana Trench begins in the western Pacific, east of the Philippines and south of Japan, near a small arc of islands called the Marianas. On a map, it's just a thin curve, but in reality it's a vast wound in the crust of the Earth, about 2,150 kilometers long, and roughly 70 kilometers wide. It's where one tectonic plate, the Pacific Plate, slides beneath another, the smaller Mariana Plate. This slow, relentless movement has been happening for tens of millions of years, creating a deep crease that drops nearly 11 kilometers below the surface. If Mount Everest were placed inside it, its peak would still be almost 2 kilometers underwater. The sheer scale of that is hard to picture, because the ocean hides its depth too well. It looks flat, reflective, peaceful. But if we could drain the water away, we'd see a world of mountains, ridges and canyons that rival anything on land. The Mariana Trench is its Grand Canyon, only instead of sandstone and sunlight, it's made of basalt, silt and darkness. Down there, pressure builds so high that it's nearly impossible to comprehend. Every 10 meters you descend, the weight of the water above you increases by another atmosphere, another 14.7 pounds per square inch. By the time you reach the bottom, the pressure is over 1,000 times greater than at the surface. It's the equivalent of having 50 jumbo jets resting on your shoulders. At such depth, nothing we're familiar with behaves normally. Steel bends, glass shatters, air compresses into nothing. Even light gives up the fight. Sunlight can only penetrate about 200 meters before it fades into blue twilight, and beyond that, into complete blackness. Below 1,000 meters, it's pitch dark, colder than you'd expect, just a few degrees above freezing. And yet, despite the crushing weight, the darkness, the cold, life exists there. Strange, fragile, and resilient. Creatures that glow in the dark, that feed on what drifts down from above, that live their entire existence without ever seeing the surface world. But before we meet them, it's worth pausing to ask something simple. Why is it that we, with all our technology, have sent probes beyond the solar system, walked on the moon, and yet can't truly explore the deepest part of our own planet? The answer isn't just about distance. The moon is 380,000 kilometers away, but it's empty space. The Mariana Trench is only 11 kilometers deep, but every centimeter of that descent pushes back against us with unimaginable force. The ocean is not empty. It's heavy, dense, relentless. And every attempt to enter it is a conversation between what we build and what the sea is willing to allow. When the first humans set out to explore the deep ocean, they didn't go far. For centuries, sailors could only guess at what lay beneath the waves. The early attempts to measure depth were almost quaint. A weighted rope dropped over the side of a ship. The line would descend until it hit bottom, then be pulled back up, measured and noted. It was tedious, imprecise, and completely inadequate for something like the Mariana Trench. The deeper the line went, the harder it became to tell whether it had hit bottom or was still swaying freely in the current. In some ways, that uncertainty became part of the ocean's mythology. It wasn't until the 19th century, with the voyages of ships like the HMS Challenger, that we began to map the deep sea more scientifically. The Challenger expedition, launched in 1872, spent nearly 4 years circumnavigating the globe, measuring ocean depths, temperatures and currents. It was during this journey that they first discovered a particularly deep sounding in the Western Pacific, the spot that would later become known as the Challenger Deep, the lowest known point on Earth's seafloor. At the time, the depth they recorded was around 8,000 meters, already staggering. Later measurements using sonar and submersibles would push that number even deeper, to 10,984 meters, give or take a few depending on where and how you measure. But measuring depth is one thing. Visiting it is another. The ocean at that pressure doesn't welcome visitors. Even a small flaw in a submersible structure, an unseen crack, a weak weld can mean catastrophic implosion. There's no margin for error. Every component must be designed to withstand forces far greater than any aircraft or spacecraft ever endures. The irony is striking. It's easier to keep a human alive in the vacuum of space than under the weight of the ocean. In space, the problem is the absence of pressure. In the deep sea, it's the opposite. Too much of it. When Jacques Picard and Don Walsh descended into the Challenger Deep in 1960 aboard the Trieste, they were entering a realm no one had seen before. The Trieste wasn't sleek or futuristic. It looked more like a giant white pill with a small steel sphere attached underneath. That sphere was where they sat. 2 men in a cramped space barely large enough to move, surrounded by thick steel walls nearly 5 inches thick. The descent took nearly 5 hours, sinking slowly through layers of water that grew darker and heavier with every passing minute. When they finally reached the bottom, the pressure outside their sphere was over 8 tons per square inch. A small window cracked during the descent, a reminder of how fragile the barrier was between them and instant annihilation. They stayed for only 20 minutes before beginning the long, slow journey back to the surface. In total, the dive lasted almost 9 hours. In the decades that followed, very few people returned to the trench. It wasn't that we lacked curiosity, but that every attempt required immense resources and risk. Machines could go deeper than humans, but even then, maintaining communication, power and control at such depths proved incredibly difficult. The pressure crushes not just metal, but also electronics, cables, sensors, anything not perfectly sealed. And the cold, near freezing, affects everything from batteries to lubricants. The sea is an engineer's nightmare and a philosopher's dream. a place where nature tests the limits of both our inventions and our imagination. Every few years, a new expedition makes headlines. James Cameron's solo dive in 2012, the DSV limiting factor missions in 2019. But even these are brief, fragile visits. They descend, touch the bottom, collect samples, record video, and then leave. We don't stay. We can't. There's no permanent presence there. No base, no ongoing human exploration. The Mariana Trench remains largely uninhabited, untouched, and unexplored. We've mapped Mars in more detail than our own seabed, and yet that inaccessibility is part of its allure. The trench represents something we can't conquer easily, something that resists our need to understand and categorize. The ocean doesn't care for our curiosity. It moves at its own pace, erases our footprints, and absorbs whatever we send down into it. The deeper we go, the less control we have. Sound travels differently, light disappears, and even time seems to lose its meaning. Instruments that work perfectly on the surface malfunction under pressure. Cameras crack, lights fail, data links go silent. It's not malevolent, it's simply physics. But it feels personal when you're trying to understand it. Still, we keep trying. Because beneath that endless blue, there's a kind of truth. A reminder that even on our own planet, mystery thrives. The Mariana Trench isn't just a place on a map. It's a symbol of everything that remains beyond reach. Every time we send a probe down, every time we measure another fraction of a meter, we're reminded that exploration isn't about conquering the unknown. It's about being humbled by it. If you were to float above the trench in a small research vessel, you'd see nothing remarkable. Just calm water, perhaps a few waves, maybe a seabird drifting overhead. But beneath you, miles below, the world is utterly alien. The light fades first, then colour disappears. Reds vanish, then yellows, until everything turns blue, then black. The temperature drops sharply. The water grows still. Sound fades. And as you go deeper, the sense of direction itself starts to dissolve. Up and down become abstract concepts. The ocean surrounds you in every direction, a pressure that feels almost alive. That's the strange paradox of the deep sea. It's a place on Earth, yet it behaves like another planet. The rules are the same, but the experience is completely different. We evolved in air, with light, with space to move. Down there, every element of life is inverted. The ocean presses inward, light dies outward, sound travels in strange ripples, and life survives in ways we can barely imagine. The trench isn't hostile because it wants to be, it's simply indifferent, and maybe that's why it feels so compelling. To explore the trench is to face something that cannot be tamed, only respected. It's an environment that reminds us how fragile our species really is, how temporary our inventions are compared to the steady patience of the Earth. The trench has existed for millions of years, shifting, deepening, swallowing the occasional piece of debris or lost vessel, then settling again into silence. We are newcomers here, brief visitors with cameras and lights, trying to make sense of a world that doesn't need us. For now, that's where we'll linger, hovering above the deepest shadow on Earth, ready to go further, but still aware that we are guests in a realm that doesn't easily share its secrets. When you look out at the ocean, it's easy to think of it as a flat surface, something you could cross with enough time and fuel. But beneath that calm lies a landscape that rivals the greatest mountain ranges of any continent. The Mariana Trench is not merely a crack in the seafloor. It is a geological scar shaped by forces that move continents, a wound cut into the crust of the earth by the slow grinding of tectonic plates. It begins far from sight, curving like a vast crescent east of the Mariana Islands, tracing the edge where the Pacific plate slips beneath the smaller Mariana plate. This process, called subduction, happens so slowly that you could stand there for a lifetime and never see it move. But given a few million years, the ocean floor reshapes itself completely. It is a motion both patient and unstoppable, and it's the reason this trench is the deepest place known on Earth. At its lowest point, the Challenger Deep, the ocean plunges nearly 11 kilometers down. That's deeper than Mount Everest is tall, deeper than the cruising altitude of most commercial airplanes. If you were to drop a pebble from the surface, it would take over an hour to reach the bottom. Down there, the water is cold, almost freezing, and the pressure is immense, over 1,000 times what you feel at sea level. It's not the kind of place you can simply visit. It's a place that has to be endured. Every meter downward adds more weight, more resistance, more silence. The trench itself isn't a single vertical drop, but a series of slopes and ridges that descend into darkness. Imagine a vast valley, its walls carved by geological time, layered with sediments and crushed rock, shifting slowly as the plates beneath continue their eternal slide. The floor of the trench is not smooth. It's a complex terrain of mud, jagged outcrops and fault lines. Earthquakes ripple through it regularly, stirring clouds of silt that drift like underwater storms. These tremors are reminders that the trench is alive, not in the biological sense, but in the way mountains breathe and volcanoes sleep. If we could stand on the bottom of the trench and look around, which we can't, at least not unprotected, we would see a world devoid of sunlight, where the concept of day and night has no meaning. Above, the surface seems infinitely far away, this ceiling of darkness stretching beyond imagination. Around you, the water presses in from all sides, dense and heavy. There is no sound, at least not the kind we recognize. The human ear isn't built to interpret the groaning of rock or the whisper of water molecules under such weight, but sensitive instruments have detected the sounds of distant earthquakes, the faint rumble of shifting plates, even the faraway calls of whales echoing down from thousands of meters above. The ocean transmits sound far better than air, and sometimes the trench becomes a resonating chamber for the movements of the Earth itself. The pressure here is not an abstract number, it's a presence. At 10,000 meters, every square centimeter of surface bears over a ton of force. To survive, any structure must be perfectly spherical or nearly so, because even the smallest flat surface can buckle under the load. That's why submersibles designed for such depths look like compact orbs, thick-walled, heavy, more like miniature planets than vehicles. Humans can't feel this pressure directly, because we're never exposed to it. The vessels we build protect us, isolating us in tiny pockets of atmosphere. But outside, the ocean would crush a human body instantly. The lungs would collapse, the blood would boil in reverse, not from heat, but from the impossibility of expansion. It's strange to think that something as simple as water can become such an unstoppable force. The same liquid that falls as rain, that fills a glass, that carries boats across its surface, becomes something almost alien when gathered in such volume. It's not that the water itself changes, but that the cumulative weight transforms it into an instrument of compression. Every molecule above adds its contribution, layer upon layer, until the mass becomes absolute. This is why we can't truly explore the trench, not in the way we explore mountains or deserts. The environment resists us not through hostility, but through sheer indifference. It doesn't care if we arrive prepared or not, And yet the trench is not lifeless. Even in that near-freezing pitch-black environment, organisms persist. Some are microscopic, living in the mud, feeding on organic particles that drift down from the surface. Others are larger, strange fish with translucent skin, eyes adapted to total darkness, and bodies built to withstand pressure that would destroy anything else. They are slow-moving, cautious, and efficient. They do not need speed or strength, only resilience. Many produce their own light, bioluminescence, small chemical reactions within their bodies that create soft glows, used to attract prey or communicate. These flashes are the only illumination in a world without dawn. When we send robotic probes into the trench, their cameras often catch glimpses of these creatures, brief flickers of movement against the void. A shrimp drifting past, a snailfish gliding along the sediment, delicate, pale, ghost-like. Each sighting raises more questions than it answers. How do these organisms survive? What do they eat? How do they reproduce in a place where finding another of your kind might take months? The deeper we look, the more we realize how little we understand. It's not that the data is incomplete. It's that the data is overwhelmed by mystery. Scientists use sonar to map the trench's contours, sending sound pulses downward and measuring the echoes that return. This method gives us a rough shape, a sense of where the ridges and valleys are, but it's like trying to understand a mountain by feeling it through a blanket. The details are lost, the texture missing. We know where the trench lies, how deep it goes, and what its general form is, but we don't know what most of it looks like in detail. Only a handful of expeditions have actually reached the bottom, and even then, each has explored only a small area, perhaps a few square meters of a landscape that spans thousands of square kilometers. It's like studying the Sahara by examining a single grain of sand. The deeper problem isn't just the pressure or the darkness, but the logistics. To explore the trench, a submersible must be designed to survive the descent, function flawlessly under pressure, and return safely. That means every piece, every bolt, wire, and seal must be engineered to perfection. There's no margin for error. Communication with the surface is limited, delayed, or lost entirely because radio waves can't travel through seawater. Instead, signals must be sent acoustically, like underwater Morse code. These signals are slow, prone to interference, and easily lost in the ocean's noise. So when a submersible descends, it's essentially alone. The ocean doesn't make exceptions for human curiosity. It's too vast for that. Even our most advanced technologies operate at the edge of their endurance. Every descent is a gamble, every success a small miracle of engineering and patience. When you hear that only a handful of people have ever been to the bottom of the Mariana Trench, it's not because of a lack of interest. It's because of what it takes to get there and return. And even when we do, the time spent at the bottom is measured in minutes, not hours. The machines can't stay longer without risk of failure. There's something humbling about that limitation. It reminds us that exploration isn't about conquering nature, but negotiating with it. We go as far as the environment allows, and when it tells us to stop, we listen. The trench is a lesson in boundaries, not just physical, but philosophical. We often think of Earth as mapped, measured, known. But here lies proof that vast regions of our own planet remain beyond reach. The deepest shadow on Earth hides not only darkness, but knowledge itself. If you think about it, there's a certain comfort in that. The idea that even with all our satellites and sensors, there are still places that remain unseen, untouched, and mysterious. The ocean keeps its secrets well. Beneath the surface, everything slows down. Light fades, sound bends, and time seems to lose its rhythm. A drop of water that falls at the surface might take centuries to circulate back up again. Down here, change happens slowly, almost imperceptibly. Sediments settle grain by grain, covering ancient bones, volcanic ash, and the remnants of marine snow, the constant drift of organic matter from above. Each particle carries the story of something that once lived near the surface, long ago. If the ocean were a library, the trench would be its archive, a place where history is stored under immense pressure. Layers of sediment preserve chemical traces of past climates, microscopic fossils, and even bits of human pollution that have found their way into the abyss. Plastic fibres, paint flakes, and metallic dust have been discovered in the deepest mud, proof that even the most remote corners of Earth aren't untouched by our presence. The realization is sobering. We can't reach the bottom easily, but our waste can. That fact alone changes how many scientists view exploration. To study the trench is not just to uncover what's there, but to confront the reality of what we've already put there. The ocean connects everything. Rivers carry debris from cities to coastlines. Currents sweep it across oceans, and gravity takes it down. The trench becomes a final resting place for what the world discards. In that sense, it's both a natural wonder and a quiet monument to our reach. But despite the challenges, exploration continues. Each new expedition pushes a little deeper, gathers more data, captures clearer images. It's not the kind of progress you can see day to day. It's measured in decades. Sometimes the most important discoveries are simply confirmations, a precise depth reading, a new species catalogued, a better understanding of how pressure affects materials. Science in the deep sea is slow, cautious, deliberate. It has to be. And maybe that's part of what draws people to it. In a world obsessed with speed and instant results, the deep ocean operates on its own timeline. You can't rush it. You can't hurry the descent. Every movement, every sound, every signal is deliberate. Down there, patience isn't a virtue, it's a requirement. The trench is often called the last frontier on Earth, but that phrase feels misleading. A frontier suggests something waiting to be crossed, a boundary to be pushed through. The Mariana Trench doesn't invite crossing. It isn't a gateway, it's an abyss. It's a reminder that not all mysteries need to be solved to be meaningful. Some can simply exist, vast and indifferent, reminding us of scale. Above it, the surface world moves on. Ships cross the Pacific, satellites trace orbits overhead, storms come and go, and somewhere below it all, that immense darkness remains untouched. The deepest shadow on Earth doesn't seek our attention. It doesn't care to be known. And maybe that's why it continues to fascinate us, because it represents something beyond reach, beyond certainty, beyond control. If you could float there, suspended between pressure and darkness, you might understand something quiet and simple. The ocean doesn't end where our knowledge stops. It continues, patiently, endlessly, like the pulse of the planet itself. And even if we never see all of it, knowing that it's there, that something so vast and unknowable exists beneath us, might be enough. It's hard to imagine what pressure really means until you try to picture the ocean as weight, not as water, but as tons upon tons of mass pressing downward in every direction. The air we live in has weight too, though we rarely feel it. Every square inch of your skin already bears about 15 pounds of air pressure, the collective force of the atmosphere. We don't notice because our bodies evolved in it, balance perfectly against it. But underwater, that balance collapses quickly. The deeper you go, the faster the weight builds. At just 10 meters below the surface, the pressure doubles. At 100 meters, it's 10 times higher. By the time you reach the bottom of the Mariana Trench, it's more than 1,000 atmospheres, an almost incomprehensible number. If you tried to swim there, you wouldn't make it past a few dozen meters without special gear. A human lung would collapse long before that. The very gases inside the body, oxygen, nitrogen, carbon dioxide, would compress and dissolve into the bloodstream. The boundaries between liquid and air that keep you alive would blur and fail. We like to think of water as soft, as harmless, but in enough quantity, it becomes a solid force, a wall that can crush steel. Every attempt to explore the trench has to begin by asking the same question. How do you build something that can bear the weight of the entire world? For most of human history, the answer was simple. You didn't. The ocean was too vast, too hostile. Sailors mapped its surface, charted its currents, but beneath the waves, everything was speculation. Some imagined giant creatures, others a smooth floor of sand. The idea that the sea might contain mountains, valleys and trenches was unthinkable. Only in the 20th century, when we began to develop materials strong enough to resist collapse, did the dream of reaching the deep truly begin. When Jacques Piccard and Don Walsh descended into the Challenger Deep in 1960, they carried that question with them. Their vessel, the Trieste, wasn't graceful. It was a compromise between engineering necessity and human stubbornness. The design centered around a small steel sphere, barely large enough for two people to sit shoulder to shoulder. That sphere was the only part capable of surviving the pressure. Everything else, the floats, the ballast systems, the outer structure, was designed to either compress safely or be expendable. The sphere itself was thick, about 13 centimeters of specially hardened steel. The windows were tiny, only a few inches across, made of plexiglass thicker than your hand. During the descent, the Trieste creaked and groaned constantly. Piccard later described hearing the sound of cracking, one of the outer windows fracturing under stress. Inside, they could do nothing but wait and trust that the sphere would hold. Outside, the temperature dropped to near freezing, and visibility disappeared entirely. Their floodlights illuminated only a few meters of water before the light was swallowed. When they finally touched the bottom, they saw a cloud of sediment rising like slow smoke, stirred up by their arrival. The entire journey down had taken almost 5 hours, and when they reached the bottom, they stayed for just 20 minutes before beginning the long, cautious ascent. That dive remains one of the most extraordinary feats in the history of exploration, not because it solved the mystery of the trench, but because it proved that reaching it was even possible. Since then, only a handful of people have repeated the feat. James Cameron's solo dive in 2012, and later Victor Vescovo's in 2019, used modern technology, stronger materials, better sensors, improved communication, but the core challenge hasn't changed. The problem isn't getting down, it's surviving there. Pressure doesn't just threaten the hull of a submersible, it affects everything inside it. Electronics must be shielded, cables reinforced, batteries insulated. Even the simplest mechanical systems behave differently under such stress. Lubricants thicken, seals deform, metals flex. Any trapped air pocket can become a weak point. That's why most deep-sea equipment is filled with incompressible fluids instead of air. Cameras, lights and sensors often operate in oil rather than vacuum, because oil doesn't shrink under pressure. The deeper you go, the more you have to think like the ocean, to build things that yield instead of resist, that move with the pressure rather than against it. For humans, though, adaptation has limits. Our bodies can't adjust to such extremes. The deepest a person has ever dived on compressed air is around 300 meters, achieved by a handful of professional divers using complex gas mixtures. Beyond that, the risk of nitrogen narcosis, oxygen toxicity, and physical collapse becomes lethal. At 1,000 meters, human exploration ends completely. Everything deeper than that belongs to machines. But even machines face a paradox. To survive the pressure, they must be heavy and rigid. Yet the deeper they go, the more that weight becomes a problem. Every additional layer of protection requires more energy to move, more fuel to descend and return. The ocean demands balance. Too light, and you'll never sink. Too heavy, and you'll never rise again. Engineers solve this with clever systems. Ballast tanks filled with iron pellets that can be released when it's time to ascend. Syntactic foams made of hollow glass spheres embedded in resin to provide buoyancy without crushing. Each innovation pushes the boundary a little further, but only a little. It's ironic that the word crush appears so often in discussions about the deep ocean. We speak of crush depth, crush pressure, crush limits. It's an acknowledgement that everything down there is at the mercy of compression. Even the materials we consider solid are not immune. Titanium bends, aluminum deforms, ceramics shatter, and yet, despite the risks, despite the sheer absurdity of sending fragile machines into a realm that wants to destroy them, we keep doing it. Not out of arrogance, but out of that quiet human curiosity that refuses to be satisfied with the surface. When scientists talk about pressure, they often use comparisons. The weight of 50 jumbo jets, the force of 10 elephants on a postage stamp. These metaphors help, but they don't quite convey the reality. Pressure underwater doesn't act from above. It comes from all sides. It's not something pushing down on you. It's something surrounding you completely, pressing equally on every surface. If you could stand inside a sphere that perfectly resisted it, you wouldn't feel anything at all. That's the paradox. Inside the submersible, the explorers feel calm, weightless, detached. Outside, the ocean is crushing itself into equilibrium. Pressure also changes how sound behaves. In the deep ocean, sound travels faster and farther than in air. The waves of energy compress the water slightly as they move, and because water is dense, the vibrations transmit efficiently. This is why whales can communicate across hundreds of kilometers, and why submarines rely on sonar instead of radio. The same pressure that limits our physical reach allows sound to carry secrets across unimaginable distances. In the trench, the noises of the world above are faint, distorted echoes, storms, ships, earthquakes, all translated into low, haunting tones that ripple through the black. But the real consequence of pressure isn't just physical, it's psychological. To imagine descending into darkness for hours, knowing that outside your small vessel lies a force strong enough to crush anything human, requires a particular kind of composure. Explorers often describe the experience as both exhilarating and terrifying. There's a moment somewhere around halfway down when the last connection to sunlight fades. The water turns from blue to black, and the realization sets in that you're utterly alone. The radio crackles, the lights flicker, and for a few seconds the ocean feels infinite. In that isolation, pressure becomes more than just physics. It becomes metaphorical. The weight of awareness, the confrontation with something so vast it erases the sense of self. Down there's no horizon, no reference point, no sound of wind or bird or wave, just the hum of machinery and the quiet thought that between you and the rest of the world lies 10 kilometers of water. The mind drifts in such silence. Some find peace in it, others unease. It's a reminder of how dependent we are on sensation, on the small comforts of air, light and sound. Even robotic missions are not immune to that psychological weight. The engineers and scientists watching from the surface feel it too, staring at screens, waiting for data, knowing that the machine they built is somewhere miles below, alone in the dark. If something goes wrong, there's nothing they can do. No rescue, no repair. The trench keeps what it takes. Despite all that, exploration continues because pressure is not just a problem to overcome. It's also a window into the nature of matter itself. The extreme conditions at the bottom of the ocean offer clues about how materials behave under stress, how life adapts to limits, and even how planets form. The minerals and microbes found in deep-sea sediments help scientists understand chemistry at high pressures, reactions that might occur inside other worlds or within Earth's own mantle. In a way, the trench is a laboratory, one that tests both the laws of physics and the resilience of curiosity. The irony, though, is that the more we learn, the more unreachable it seems. Every discovery points to greater complexity. The microorganisms that thrive there defy expectations about biology. The rocks reveal histories of volcanic activity, earthquakes, and continental movement that span millions of years. The deeper we study, the more the trench becomes not a destination, but a mirror of our own limitations. Pressure defines the ocean, but it also defines us. We live under constant invisible forces: gravity, atmosphere, expectation. And like the submersibles we build, we find ways to endure. The trench reminds us that survival isn't about eliminating pressure, it's about existing within it. Everything on Earth, from the smallest cell to the largest mountain, is shaped by forces it cannot escape. The difference is only one of degree. So when we say we can't truly explore the Mariana Trench, what we mean is that we can't yet exist comfortably within its rules. Our bodies, our machines, our minds are all built for the surface. The trench is a reminder that the world we inhabit is layered, and most of it is inaccessible to us. We've mapped the continents, crossed the skies, even looked beyond our planet, but right beneath our feet lies an environment that remains almost untouched. It's tempting to think of that as a failure, but maybe it's not. Maybe the trench serves a purpose simply by existing beyond our reach. It reminds us that mystery has a place in the modern world, that there are still frontiers not meant for us, not because we aren't clever enough, but because the planet itself has boundaries we can't bend. The ocean keeps its secrets with quiet dignity, and in doing so, it gives us something rare: humility. The next time you look out at the sea, try to imagine that weight, the mass of water stretching downward farther than mountains rise upward. Beneath every ripple, there's pressure building, accumulating, shaping the world in ways we can't see. And somewhere far below, in a darkness that no light can reach, that pressure holds the silence of the earth itself. It is steady, patient, immense, the true weight of the world. The farther you descend, the more the ocean begins to shed the world you know. At first, there's still light, a shimmering blue that dances on the waves, bending and flickering as it filters down through the water. Divers call it the photic zone, the realm of sunlight. It's where coral reefs thrive, where fish shimmer like living jewels, where life feels abundant and visible. But light is fragile here. Every meter steals a little more of it. Reds vanish first, then oranges, then yellows. By 100 meters, you're surrounded mostly by blue, and by 200, even that starts to fade. Below 1,000, there's nothing left. Darkness takes over, absolute and unbroken. The world above disappears completely. That darkness isn't like turning off a light in your room. It's thicker, almost physical. The human eye never truly adapts to it, because there is no faint glimmer, no reflection to orient yourself. You could stretch your hand out in front of you and see nothing, not even the outline. Down here, sight ceases to be useful. The ocean becomes a world of touch, vibration, and sound. The deep sea isn't empty, but it is invisible, and that difference changes everything. When explorers first reached these depths, they expected lifelessness, a barren seafloor, cold and still. But the truth is stranger and far more beautiful. Even without sunlight, life persists, glowing faintly in the dark like scattered embers. Bioluminescence, the ability to produce light through chemistry, is the ocean's quiet rebellion against the void. Tiny plankton release flashes to startle predators. Jellyfish drift like translucent lanterns, pulsing with gentle blue light. Fish carry glowing lures to draw in prey. The darkness isn't empty, it's alive with whispers of light, each one fleeting, purposeful, delicate. Some of these creatures create light through symbiosis, hosting colonies of bacteria that emit a steady glow. Others mix chemicals within their own bodies to create a spark when needed. The reactions are remarkably efficient, producing almost no heat, just pure luminescence. In the deep, that efficiency is survival. There's no waste, no excess, no sunlight to compete with. The glow is communication, camouflage, deception, and beauty all at once. Bioluminescence may seem magical, but it's also practical. For many species, light is a weapon or a warning. Some fish can release bursts of brightness to blind predators temporarily, while others mimic the faint glow of the distant surface to blend in from below, a trick called counter-illumination. In a world with no landmarks, light becomes the only language, and every flicker carries meaning. To see it in person is to witness something close to a dream. Scientists who've observed these creatures from submersibles describe it as drifting through a star field. Except here, the stars move. They pulse, spiral, and vanish, replaced by others that appear just as suddenly. It's a cosmos turned upside down, stars below instead of above, and instead of endless emptiness, there's water carrying the faint echoes of life. But for all its beauty, this darkness is still hostile to us. Without light, there's no warmth. The temperature hovers near freezing, just above the point where seawater would solidify. The cold is constant, unwavering. It seeps into metal, into glass, into any unprotected surface. Machines slow down, batteries drain faster, and any trace of heat dissipates instantly. The darkness and cold aren't separate. They are partners, each reinforcing the other, eroding anything that doesn't belong. Even time feels different here. On the surface, light divides the day into hours, gives rhythm to life. Below, there are no such cues. There's no dawn or dusk, no concept of morning or night. For the creatures that live here, time is marked not by sunlight, but by the faint drift of food from above. Tiny particles of organic material known as marine snow. It's a constant, delicate fall of debris from the living world higher up. Dead plankton, fish scales, fragments of plants, microscopic dust. Over months and years, this slow rain sustains everything below. Imagine that for a moment. The entire ecosystem of the deepest ocean relies on what trickles down from life that never knew it existed. It's an odd kind of connection, fragile, indirect, but absolute. If the upper oceans faltered, the abyss would starve. Down here, everything depends on patience. Food is scarce, energy precious. Many creatures move slowly to conserve energy. Their metabolism's reduced to the bare minimum. They don't chase, they wait, they drift, they endure. There's a quiet philosophy to that way of living. In a realm where light, warmth, and abundance are gone, survival isn't about dominance but adaptation. You don't fight the darkness, you learn to live within it. The animals of the deep seem almost like meditations on that principle. The snailfish, soft-bodied and pale, thrives at depths where no other vertebrate can survive. The amphipods, tiny crustaceans that scavenge the sea floor, have bodies reinforced not by hardness but by flexibility. They bend rather than break. The darkness shapes everything here, not through violence but persistence. When scientists bring samples up from the trench, most of these creatures don't survive the journey. The change in pressure is too extreme. What was normal for them becomes fatal at the surface. Their bodies swell, sometimes burst, their cells unable to cope with the sudden expansion. It's a reminder that our world, comfortable as it seems, is just another environment among many, and not the default. To them, our light-filled atmosphere would be as lethal as their darkness is to us. That's part of why we can't truly explore the trench. It's not only a matter of technology or danger, it's that we don't belong there. The physics of our existence depend on sunlight, on moderate pressure, on warmth. The deeper you go, the more alien it becomes, not because it's far away, but because it operates under different rules. In the absence of light, evolution writes in other languages. Sight gives way to sensitivity, colour to chemistry, warmth to endurance. And then there's the psychological dimension. Darkness that deep doesn't just hide things, it changes perception itself. Inside a submersible, surrounded by pitch black, the human brain begins to invent sensations. You might think you see movement where there is none, or feel motion even when the craft is still. The lack of visual reference makes orientation difficult. Up and down lose meaning. The mind tries to fill in the void, to make sense of an environment that offers no cues. Astronauts describe a similar disorientation in space, but at least there are stars. In the deep ocean, there is only the hum of machinery, and the thought that the nearest surface is kilometers away. For researchers who spend years studying these environments, the fascination often becomes personal. They talk about the deep not as a hostile place, but as one of reflection. There's something about staring into a darkness that has existed unchanged for millions of years that humbles even the most confident scientist. It's a confrontation with scale, with how small we are compared to the systems that sustain the planet. The trench is one of those places where the boundaries of science and philosophy blur. You can measure pressure, temperature, and salinity. You can catalogue species, analyse sediment, and model geological processes. But none of that explains the feeling of looking into that void. It's not fear exactly, more a recognition of otherness. The deep is not designed for us, and perhaps that's what makes it sacred in a quiet scientific way. It's an environment untouched by sunlight, unbothered by time, where life exists on terms completely its own. Even the light we bring with us, flood lamps, LEDs, laser scanners, feels intrusive. The moment the beams cut through the water, they disturb everything. Creatures scatter, sediment rises, and the stillness disappears. Every observation changes the thing being observed. In that sense, exploration is always imperfect. To see the trench, we must first disrupt it. The deeper truth remains hidden in the undisturbed dark beyond our reach. It's easy to romanticize darkness as mystery or metaphor, but here it's simply reality. The absence of light is complete. Every photon is absorbed or scattered long before it can travel far. Even laser beams, which can travel miles through air, fade after just a few dozen meters underwater. Cameras struggle to focus, instruments to orient. In a strange way, the trench is less a place and more a condition, a set of extremes that erase ordinary perception. And yet, in that erasure, life finds simplicity. The creatures that live there don't need complex eyes or bright colours. They navigate by vibration, by chemical gradients, by the faint echoes of movement. The darkness simplifies everything to its essentials: hunger, motion, survival. It strips away the unnecessary until what remains is pure function. It's not bleak, it's efficient. When you think of how much of Earth's biosphere exists in darkness, it's staggering. The majority of the ocean is beyond the reach of sunlight, and within that enormous volume lives most of the planet's life by mass. The deep sea isn't the exception, it's the rule. We, on land and in the shallows, are the outliers, the ones adapted to light. From that perspective, the Mariana Trench isn't an alien world. It's the true face of our planet. We call it darkness because we can't see it, but for the organisms that live there, it's home. Their senses are tuned to subtle changes in pressure, to minute vibrations, to chemical signals drifting in the water. To them, we are the blind ones, living in a thin, bright layer that flickers on the surface. The trench reminds us that light is not the measure of life, just the measure of what we notice. There's a peculiar irony in how we study this place. We bring cameras and lights, instruments that depend on visibility, into a world where visibility doesn't exist. We illuminate, observe, record, and then leave, taking our light with us. For the trench, it's as if we were never there. The darkness closes behind us, unchanged, indifferent, and perhaps that's how it should be. Some environments don't need our constant presence to be meaningful. The Mariana Trench doesn't ask to be seen. It simply is. Its darkness holds no malice, no secret agenda. It's not hiding anything. It's being itself, as it has for millions of years. If we can't truly explore it, it's not because it resists us. It's because our tools, our senses, and our expectations were never designed for that kind of world. Still, there's something magnetic about it. We're drawn to the idea of the unseen, to the notion that beneath our familiar world lies another, silent and eternal. That curiosity is what keeps scientists sending probes, keeps engineers refining designs, keeps storytellers imagining what might dwell below. We'll never stop wondering what the darkness contains. If you were sitting now inside a submersible drifting through that blackness, you'd hear only the faint hum of pumps and motors, the occasional creak of metal adjusting to pressure, maybe your own breath in the headset. The light from your instruments would reach only a few meters ahead, revealing shapes that dissolve almost as quickly as they appear. You'd see clouds of particles drifting by like snow, illuminated just long enough to remind you that you're moving through a space filled with unseen life. Then, beyond that, only nothing. A darkness beyond light, beyond comfort, beyond comprehension. That's the realm we're trying to understand. A world that begins where our senses end. a reminder that the universe doesn't need our permission to exist. And somewhere far above, the sunlight glitters on the surface, unaware of the depth below, just as most of us live unaware of how much lies beneath the calm. If the deep ocean is another world, then the machines we send there are its astronauts. They breathe for us, see for us, and survive where we cannot. Every submersible, every remotely operated vehicle, every probe that disappears beneath the surface carries a fragment of human curiosity into a realm that would destroy us in seconds. The ocean doesn't invite exploration, but it doesn't forbid it either. It simply waits, and in that waiting, we keep trying to build something capable of listening to its silence. From the outside, deep-sea submersibles look simple, smooth, rounded, compact. But that simplicity hides the most intricate engineering on Earth. Every surface, every seam, every bolt must be designed to withstand pressure that could collapse a building. The rules are unforgiving. There's no room for weakness, no tolerance for error. At 11 kilometers down, the difference between safety and catastrophe is measured in millimeters of steel and seconds of luck. When engineers began building the earliest deep-diving vessels, they weren't trying to explore, they were trying to survive the idea of depth itself. The Trieste was an audacious experiment, a test of whether steel could outlast water. Later submersibles refined that idea but never escaped its paradox. The ocean is too heavy, too cold, too isolating to be conquered. So we build machines that don't fight it. They adapt to it, just as the creatures in the abyss do. They breathe oil instead of air, carry no fragile spaces, no unnecessary emptiness. In a sense, they're closer to the life of the deep than to the humans who designed them. Every expedition begins the same way, with a slow descent. Whether manned or unmanned, the machine slips below the surface and leaves the world of sound and light behind. Communication weakens, the signal lags. On the surface, the operators watch screens filled with numbers, depth, temperature, pressure, battery life. Each descent is a negotiation with physics. Go too fast and you risk damaging the hull. Go too slow and the currents carry you off course. There's no steering wheel in the deep, no reliable sense of direction. The machines navigate by acoustic pings, sonar reflections, tiny bursts of sound that bounce off the seafloor and return distorted, delayed, uncertain. At certain depths, the ocean becomes layers of density. Warm water above, colder below, with invisible boundaries that bend sound and light. A submersible passing through these layers feels them as soft jolts, like shifting from one world to another. The operators monitor every meter, every fluctuation in pressure. A single valve malfunction, a miscalculation in ballast can trap the craft forever. The ocean doesn't return what it takes. Modern machines are remarkable, but even they are fragile. The remotely operated vehicles, ROVs, used today can dive for hours, capturing video, collecting samples, mapping terrain. They're tethered to their motherships by long cables, sometimes miles in length, carrying both power and communication signals. That tether is their lifeline, but also their weakness. A sudden current can twist it. A sharp rock can cut it. A mechanical fault can reel it in too soon. Every dive risks losing the connection entirely, leaving the machine drifting in silence. When that happens, recovery becomes nearly impossible. The ocean floor isn't flat. It's filled with ridges, trenches, and loose sediment. A lost ROV may fall into a crevice or become buried in silt, invisible even to sonar. Sometimes the engineers try to send signals for days, hoping for a faint reply. Most of the time, it never comes. The deep doesn't let go easily, and yet, for all those risks, we keep sending them back. Because every time one of those machines descends, it carries a chance of discovery. The first high-resolution images of the Challenger Deep, the samples of unknown microbes, the recordings of strange clicks and groans that might be geological or biological, we owe all of them to the machines that breathe for us. They're built to withstand conditions beyond comprehension, but they're also delicate in ways that surprise you. Cameras, for instance, must operate in absolute darkness, capturing light from artificial lamps that illuminate only a few meters ahead. Those lamps must be designed to survive the crushing pressure without shattering. Every watt of power must be accounted for. The batteries that run these systems have to function in near-freezing temperatures, where ordinary chemistry slows to a crawl. Heating systems can't rely on convection, because the water around the machine is too dense to carry heat efficiently. Every function, from movement to vision, has to be reinvented for an environment that obeys no familiar logic. There's a kind of poetry in that design, though not the romantic kind, more the poetry of precision. Every piece of a deep-sea submersible is a solution to a problem that exists nowhere else. The spherical pressure hull, the buoyant foam, the ballast release mechanisms, all of it exists because the ocean demands it. Even the materials are chosen not for elegance but for endurance. Titanium resists corrosion, syntactic foam maintains buoyancy under pressure, and certain plastics behave more predictably than metals in extreme cold. To build for the deep is to surrender aesthetics for survival. The people who design these machines rarely see the depth themselves. Most of their work happens on land, in quiet laboratories filled with prototypes and pressure chambers that simulate thousands of atmospheres. They test, fail, rebuild, and test again. Each iteration brings them closer, but never close enough. The deep always has the final say. When James Cameron descended to the Challenger Deep in 2012, he did so inside the Deep-Sea Challenger, a vessel unlike any before it. It was tall and narrow, shaped like a torpedo, painted bright green. It looked more like a missile than a submarine. Inside, there was just enough space for him to sit, surrounded by controls and monitors. The pressure hull was made of specialized materials, the lighting and cameras custom-built for the extreme depth. The descent took about 2.5 hours, and once at the bottom, he spent nearly 3 hours exploring. In those hours, he became one of only a handful of people in history to see that place with his own eyes. He described the view as monochrome, like drifting across a desert. The seafloor was covered in fine sediment, pale and soft, disturbed easily by the craft's movement. There were no colours, no features, no sound, just silence and the faint whir of his equipment. Occasionally, small organisms drifted by, shapes without names. He collected samples, recorded video, then began the long journey back to the surface. When he resurfaced, sunlight seemed unreal. After hours in darkness, the brightness of day felt like waking from a long dream. That's something almost every deep-sea explorer says. The first glimpse of light after a dive feels like a rebirth, as if they've been away longer than they actually have. The ocean below takes time differently. For remotely operated vehicles, there's no such relief. They return mechanically, silent, their data stored on drives, their footage waiting to be examined. And in those images, the world below looks both alien and strangely familiar. Sediment rippling like dunes, occasional rocks shaped by unseen forces, creatures that seem to hover in mid-water like thoughts half-formed. The footage rarely provides answers. More often it generates questions. Each dive leaves behind hours of video, terabytes of sensor data, samples of mud and water. Teams spend months analysing it, trying to extract meaning from what the machines saw. The irony is that while our technology extends our senses, it also reminds us of their limits. The camera records what it can see, but not what it feels like to be there. The sensors measure temperature and salinity, but can't capture silence, stillness, or scale. Even the best recordings flatten the experience into numbers and pixels. There's a quiet dignity in these machines, though. They don't complain, don't tire, don't fear. They descend again and again, sometimes for days, sometimes for minutes, each time pushing the boundary of what we know. They are our lungs in the deep, our eyes in the dark. They make the impossible slightly less so. The phrase, machines that breathe for us, isn't just metaphorical. Some systems literally simulate respiration, exchanging heat and chemicals in cycles that mimic metabolism. The fluids inside their hydraulic systems expand and contract, regulating pressure the way lungs regulate air. Their lights pulse like heartbeats. Their propellers spin like fins. In the absence of life, we've built mechanical life, and when one fails, when an ROV is lost to the abyss, it feels less like the loss of equipment and more like the loss of a part of ourselves. Every recovered machine tells a story. Some come back scarred, their outer shells dented, their sensors corroded, their cameras cracked. Engineers study the damage the way biologists study fossils. Each mark is a lesson about the ocean's force, each failure a step toward resilience. That's how progress works down there. Not through triumph, but through attrition. The strangest thing about deep-sea machines is how quiet they are. In space, motion is graceful, but in water, it's deliberate. Propellers spin slowly to avoid stirring sediment. Arms move carefully to prevent shaking the craft. Every sound is amplified in the dense medium. The click of a manipulator claw, the hum of a motor, the creak of expanding metal. To human ears, it would sound like being inside a sleeping giant, the noise of breathing turned mechanical. When scientists pilot these machines remotely, they talk about developing an intuition, a kind of shared rhythm between human and robot. The operator feels the resistance through the controls, senses the weight of the machine as it moves through layers of pressure. It's almost like an extension of the body, one that stretches miles below. That connection, fragile as it is, bridges the gap between worlds. We often think of technology as cold, detached, but here it becomes intimate. A submersible isn't just a tool, it's a partner in curiosity, a surrogate presence. It goes where we cannot, endures what we can't imagine, and returns bearing fragments of the unknown. Through it, we extend the reach of human perception into a place utterly beyond us, and still, despite all our progress, we haven't built a machine that can stay there indefinitely. The trench doesn't allow permanence. The pressure, the cold, the corrosion, all conspire to shorten the lifespan of every device we send. A few hours, maybe a day, and then the batteries fade, the system shut down, and the machine drifts until retrieved. We visit, but we do not inhabit. That, perhaps, is the defining truth of our exploration. We build machines that breathe for us because we can't breathe there ourselves. The deep ocean remains off-limits to flesh and bone. Every descent is a temporary conversation, a brief exchange between two very different worlds. The machines descend, listen, record, and return, and in their silence we hear the echo of our own limits. Still, you keep building, refining, dreaming. Because to stop would mean accepting that there are places we will never understand, and that acceptance doesn't come easily to us. The drive to explore is not logical, it's instinctive. We design these machines not just to collect data, but to remind ourselves that curiosity can survive even where humans cannot. The ocean doesn't change because we visit it. It remains dark, cold and immense, indifferent to our presence. But we change every time we reach a little deeper. The machines that breathe for us are more than instruments. They are reflections of the part of us that refuses to stop wondering, even when the world presses back with the weight of 1,000 atmospheres. And above, on the surface, the ship waits. Waves rise and fall, clouds drift, and somewhere far below, a tiny light flickers in the black. A signal, faint but steady, returning from a place almost beyond reach. It's enough to remind us that even in the deepest dark, we're still capable of finding a way to see. The machines can survive where we cannot, but every descent still begins and ends with people. Behind every dive, every signal received from the deep, there are engineers, pilots, biologists and technicians who spend years preparing for a few hours of contact with the unknown. The trench may belong to the machines physically, but it is still the human mind that sends them there. And that's the paradox of exploration. No matter how mechanical it becomes, it is always a human story. When people talk about deep-sea exploration, they often focus on the technology, the pressure-resistant hulls, the titanium joints, the power systems that function in freezing water. But what rarely gets attention is the toll it takes on the people involved. The surface teams live with constant tension, waiting for signals from machines that might never return. The pilots who descend inside those vessels carry the awareness that a single failure could mean instant death. The scientists who analyze the footage confront the realization that the mysteries they're studying exist in a world they'll never truly experience firsthand. The deep sea humbles everyone it touches. For those who actually go down, the experience is unlike anything else. Sitting inside a pressurized sphere with just enough room to move your arms, surrounded by metal thicker than your entire body, there's no illusion of control. There's a strange intimacy to it. The hum of the pumps, the clicking of valves, the faint creak of the hull flexing under pressure. You're aware that only a few centimeters of metal separate you from 10,000 meters of crushing force. It's not like flying an airplane where you can see the horizon. There's no horizon here, no sky, no landmarks. Just the slow descent into a darkness that never ends. Some describe it as peaceful. Others say it's terrifying. Most admit it's both. The first few hundred meters feel familiar enough. You can still see light fading, the water shifting from turquoise to indigo to black. But after a certain point, maybe a kilometer or two down, you lose all visual connection with the surface. The only light is artificial. The sense of movement disappears. Without anything to reference, you could be falling forever or hovering in place. Your body can't tell. The instruments say you're descending, the numbers ticking upward, the pressure increasing, but your senses have no anchor. That disorientation can be overwhelming. Humans depend on sight more than any other sense, and when that's gone, the mind struggles to stay grounded. Pilots of deep-sea vessels train to manage that feeling, to trust the instruments when their instincts rebel. They rehearse in simulators, spend hours practicing emergency protocols, learn to interpret the faint feedback of the craft systems as though it were a heartbeat. But all the preparation in the world can't erase the moment when you realize how alone you are. There's also the sound, or rather, the lack of it. At that depth, silence is total. On the surface, even in calm weather, you can hear the wind, the creak of the ship, the distant call of birds. Below, all of that disappears. The only sounds are mechanical, the slow hum of motors, the faint hiss of the air scrubbers, an occasional metallic groan as the hull adjusts. Some explorers describe hearing their own heartbeat through the headset. Others say that the silence feels like pressure itself, a weight that grows heavier the longer you sit in it. Inside the submersible, the air is recycled, dry, metallic. The temperature drops with the depth. The instruments glow faintly, illuminating faces that grow paler as the hours pass. Conversation becomes minimal. There's nothing to say except updates. Depth, temperature, orientation, battery life. Everything else feels out of place, almost disrespectful in the presence of so much stillness. You stop thinking about words and start listening, not for anything specific, but for the subtle rhythm of the machine around you, as though it were breathing for you. For those who descend in pairs, there's a strange intimacy. You share a space smaller than a car trunk, sealed in with another person for hours. Every breath, every movement, every decision must be coordinated. There's no room for conflict or ego. The ocean doesn't allow that. You depend on each other completely. One miscalculation, one moment of distraction, and the dive could end in disaster. It's not just trust, it's surrender. You have to let go of the illusion of control and accept that you're part of something much larger, much heavier, much older than yourself. Psychologists who study extreme environments compare deep-sea exploration to spaceflight or polar research. Isolation, confinement, monotony, and risk create a unique psychological landscape. The mind reacts in unpredictable ways. Some divers report heightened clarity, an almost meditative calm. Others experience time distortion, minutes stretching into hours, hours collapsing into moments. There's also what researchers call the overview effect, similar to what astronauts describe when seeing Earth from orbit. A sudden awareness of scale, of fragility, of connection. Except here, it's inverted. Instead of looking down on the planet, you're looking up toward it, from a place that feels alien but belongs entirely to it. There's also fear. Even the most experienced explorers admit to it. Fear of failure, fear of isolation, fear of the unknown. It's not irrational, it's biological. The human body isn't built for darkness and pressure. The instincts that kept our ancestors alive in caves and forests start to misfire in the abyss. The brain senses danger in every sound, every flicker. In training, they teach you to focus on routine. Check the gauges, record the data, breathe evenly. But deep down you know that routine is the only thread keeping your mind from unraveling. It's not just the descent that tests you, it's the waiting. Once you reach the bottom, there's rarely much to see. The lights reveal a few meters of terrain, pale sediment, occasional rocks, maybe a small creature drifting by. It's hard to describe the disappointment and awe that come together in that moment. You've travelled to the deepest point on Earth, only to find stillness. It's humbling in a way that nothing else is. You realise that all the danger, all the technology, all the preparation was for a glimpse of something that has been there for millions of years, unchanged, unaware of you. The return to the surface brings its own kind of anxiety. Ascending takes hours, and every minute is a test of endurance. The pressure lessens, but slowly. The submersible rises through layers of water that each have their own currents, their own temperatures. Communication with the ship above remains limited. You don't know if the weather has changed, if waves are waiting, if the winch line will hold. There's nothing to do but wait and watch the numbers on the depth gauge fall. Some explorers describe that as the hardest part, the waiting. The knowing that the danger isn't over until you see sunlight again. On the surface, the recovery crew cheers, cameras flash, but the people inside the craft rarely smile right away. They're exhausted, dehydrated, sometimes nauseous. The transition from darkness to daylight feels unreal. The air smells different, heavy with salt and warmth. For a moment, the world feels too bright, too loud. The mind struggles to adjust, as if it had been somewhere sacred and now has to return to the noise of ordinary life. Many describe feeling quiet afterward, not out of fear or fatigue, but because words don't fit the experience. Even for those who never dive, the trench leaves its mark. The scientists studying samples brought up from the deep talk about a strange kind of reverence. The mud, the microorganisms, the fragments of rock. They are pieces of a world that no human can inhabit. Handling them feels like holding something sacred, something ancient and indifferent. They clean their instruments carefully, catalogue the samples meticulously, and yet they know they've disturbed something that had existed in silence for millennia. For the engineers, the emotional connection is different but no less powerful. Each successful dive is a triumph of human precision against natural indifference. But it's also a reminder of fragility. Every time they send a submersible down, they know that something could go wrong. The ocean doesn't forgive mistakes. The machinery represents years of work, millions of dollars, and countless hours of planning, and yet it can vanish in seconds if one seal fails. That awareness weighs on them constantly. Success and loss are separated by fractions of pressure, by moments of timing. There's also the question of purpose. Why do it at all? Why risk so much for a place that yields so little? The answers vary. For some, it's scientific. The chance to study new species, new geological processes, new frontiers of chemistry and biology. For others, it's philosophical. The desire to confront the limits of human understanding. For many, it's personal. A need to be part of something larger, to touch the edge of the unknown. Whatever the reason, the motivation always traces back to the same impulse: curiosity. That curiosity defines the human factor more than anything else. It's what drives exploration despite the danger, the cost, the uncertainty. We're drawn to the places that resist us, perhaps because they remind us that we're not as powerful as we think. The trench doesn't care about our ambitions, but we keep returning, not to conquer it, but to listen. In a way, every dive is an act of humility, a recognition that understanding comes not from domination, but from presence. There's something profound about that, the idea that to explore the world, we must first accept our smallness within it. The people who dedicate their lives to studying the deep ocean aren't just scientists or explorers, they're caretakers of mystery. They preserve the unknown by refusing to let it vanish into myth. They remind us that mystery still exists, that it's not something to be erased by technology, but something to coexist with. The human factor is what keeps the story alive. Machines can descend, record, return, but they don't dream. They don't wonder what it feels like to touch the bottom of the world, to look up and see nothing but water between you and the stars. They don't imagine what lives beyond the reach of their lights. We do, and that imagination is the bridge between the surface and the abyss. There's a quiet honesty in knowing that some things will always be beyond us, that no matter how advanced our tools become, we'll never fully belong in the trench. But perhaps belonging was never the point. The deep ocean doesn't need us, but we need it. As a reminder of perspective, as proof that discovery still exists, as evidence that the world is larger than our comprehension. That's what keeps the human factor at the heart of every expedition. It's not the data or the footage or even the discoveries that matter most. It's the act itself, the willingness to go, to risk, to wonder. The ocean tests our machines, but it also tests our patience, our courage, and our humility. Every dive is a conversation between curiosity and consequence, between fragility and persistence. And when the lights fade, when the instruments are turned off and the submersible rests again on deck, what remains is that human pulse behind it all. The quiet determination to keep asking questions, even in the face of silence. Because the ocean doesn't answer us in words, it answers in pressure, in darkness, in time. And we, endlessly curious, keep listening. Silence is never truly silent. It's easy to forget that when we talk about the deep ocean as quiet or still, what we really mean is that it's quiet to us. Down there in that heavy darkness, sound moves differently. It travels faster, farther, deeper. It bends through layers of temperature and salinity, curving around ridges, echoing through trenches. The deep ocean isn't a void, it's a body filled with vibration, and everything in it, from the smallest shrimp to the largest submarine, is part of that chorus. But to human ears, it feels like silence, because we can't interpret the language of pressure and water. We mistake what we don't understand for absence. When the first hydrophones were lowered into the ocean decades ago, scientists expected to hear very little. Instead, they found a constant murmur, a living backdrop of clicks, rumbles and low frequencies. Some of it came from geological activity, the Earth itself moving and breathing through its faults. Some came from animals, whales communicating across entire oceans, fish drumming against their own bodies, shrimp snapping their claws with enough force to create tiny bursts of light and heat. Even the slow grinding of tectonic plates makes a sound, though it's too deep for us to hear without amplification. The ocean is a landscape of invisible motion, and sound is the only way to map it. In the Mariana Trench, where light fails completely, sound becomes everything. For the creatures that live there, it replaces sight, touch, even memory. Some species have evolved specialized organs that detect pressure waves, letting them sense movement hundreds of meters away. Others use pulses and clicks like sonar, bouncing their own signals off the world around them. Where humans would see darkness, they hear structure. The trench floor is a labyrinth of echoes, a place where distance is measured not in meters, but in milliseconds of return time. For scientists, those echoes are the only way to explore without being there. Modern oceanography relies heavily on sonar, sound navigation and ranging. A transducer sends a pulse downward, and the returning signal tells you what lies beneath. The longer it takes to return, the deeper the water. The way it scatters reveals whether it hit rock, sediment, or life. With enough pulses, you can build a map, a ghostly topography made entirely of reflected sound. It's not perfect. Sound bends when it passes through water of different densities, and the deeper you go, the more unpredictable it becomes. But it's the best tool we have. The irony is that even with our most advanced systems, what we hear from the trench is less like a song and more like static. The ocean adds its own interference, and the deeper you listen, the more complex the noise becomes. Each vibration overlaps with another until the line between source and echo blurs. Sometimes scientists spend weeks trying to identify a single sound, a low-frequency moan, a sharp ping. a rumble that rises and falls without pattern. Some of those sounds turn out to be natural phenomena, the collapse of a distant landslide, the shifting of sediments, or the explosion of gas bubbles trapped for centuries. Others remain unidentified. There's one recording made in the Western Pacific near the Mariana region, known among researchers as the upsweep. It's a strange rhythmic sound that rises and falls like a slow mechanical heartbeat. It's been heard seasonally for decades, detected by hydrophones thousands of miles apart. No one knows for sure what causes it. The leading theories involve volcanic vents or underwater eruptions, but no one has found a direct source. Whatever it is, it's a reminder that the deep still hides its voice, even from the best instruments we've built. Listening to the ocean requires patience and humility. Hydrophones are dropped into the depths, left for months, sometimes years, to collect data. When they're retrieved, the recordings are long stretches of subtle noise punctuated by moments of clarity, a distant quake, the call of a whale, the faint metallic echo of a ship passing far above. These recordings become a kind of diary for the planet. They capture storms from thousands of miles away, earthquakes that shake the seafloor, even the faint hiss of icebergs carving in polar seas. The ocean carries sound so efficiently that events on one side of the world can be heard on the other, if you know how to listen. And yet, for all that activity, being inside it feels like complete silence. Explorers who have descended into deep submersibles describe an absence of sound so total it becomes disorienting. The hull blocks most external noise, and the thick water absorbs the rest. The human ear, deprived of stimulus, starts inventing it. You begin to hear things that aren't there. A faint whisper, a thump, the imagined echo of your own heartbeat. The mind reaches for pattern, for something familiar, but there is none. The silence presses in from every direction, so heavy it becomes almost tactile. That sensation has a psychological effect. In everyday life, silence is rare. Even in the quietest rooms, there's always some noise, the hum of electricity, distant movement, the rhythm of your own breath. In the trench, even that is muted. The mind starts to wander, filling the void with memory and imagination. Some divers report a kind of calm, others unease, but all describe the same awareness, the feeling of being inside something vast and alive that simply doesn't notice you. It's not hostile, just indifferent. The silence is not emptiness, it's fullness beyond comprehension. Sound, for humans, has always been tied to communication and presence. When it disappears, we lose part of our orientation. That's why deep-sea silence feels so alien. It's not the absence of noise, it's the absence of confirmation that you still exist in relation to something else. You're alone with your thoughts, your heartbeat, and the steady, unfeeling breath of the ocean around you. It's a kind of solitude that few people ever experience, because even space isn't like this. In orbit, at least, there's a view. In the trench, there's only black and the suggestion of motion. And yet, paradoxically, the ocean is one of the loudest environments on Earth, just not to us. Whales communicate across entire basins, using frequencies so low they pass unnoticed by human ears. The deep groans of blue whales can travel for thousands of kilometers. A single vocalization can cross an ocean. These sounds weave through the darkness, layering across centuries, forming a slow-moving symphony of living and geological voices. Fish, crustaceans, even coral reefs contribute. On a healthy reef, the noise of snapping shrimp and feeding fish is constant, a crackling hum that can be heard for miles. In the deep, those sounds fade, but they never disappear entirely. The world without sound is in truth a world beyond our hearing. We've begun to realize how much human activity has changed that soundscape. Ships, sonar systems, drilling operations, all add artificial noise to the ocean. To a whale, a cargo ship is deafening, a wall of mechanical vibration that masks their communication. To smaller creatures, the constant thrum of engines may be disorienting or even fatal. Scientists have recorded increases in stress hormones in marine animals during periods of heavy shipping traffic. The ocean's music is being rewritten by us, often without intention. Even the deepest waters aren't immune. Hydrophones in the Mariana region have detected the faint hum of faraway ships, the rhythmic pulse of sonar from naval exercises, even the tremors of distant seismic surveys. It's unsettling to know that our presence reaches even there, carried not by light or debris, but by sound. The trench, which should be the quietest place on Earth, now echoes faintly with human industry. The irony is almost poetic. We can't physically go there easily, but our noise can. We've become part of the planet's soundtrack, whether we mean to or not. Still, sound remains one of the few ways we can study the trench without disturbing it. Acoustic monitoring lets scientists detect changes in currents, volcanic activity, and even life cycles. The faint recordings of animal calls reveal migration patterns, feeding habits, and communication strategies that would otherwise be invisible. In recent years, researchers have discovered entire soundscapes associated with deep-sea ecosystems, rhythms that repeat daily, seasonally, annually. These aren't random noises. They're patterns of life unfolding in perfect darkness. When you listen to these recordings sped up, they sound almost musical, a chorus of clicks, hums, and pulses, layered over the deep resonance of the Earth itself. There's rhythm in the way sediment shifts, melody in the calls of whales, harmony in the crackle of distant vents releasing heat. It's easy to forget that every one of those sounds represents movement, energy, life. In a world without light, sound becomes not just communication, but memory. The ocean remembers everything that touches it through vibration. Perhaps that's why explorers often describe the silence of the deep as contemplative rather than frightening. It's not that nothing is there, it's that everything is there, beyond perception. The human ear, trained for air, can't process it. The pressure changes how sound waves behave, compressing their frequencies, stretching their decay. Even our instruments translate them imperfectly. We listen through layers of distortion, and in doing so, we glimpse how little we actually hear of the world. When you think about it, the ocean and the human mind share that quality. Both are filled with noise beneath the surface, currents of thought, buried motion, echoes that never quite fade. Silence, in both, isn't emptiness, it's depth. The longer you sit in it, the more you begin to sense that there's something moving just beyond comprehension. In the deep sea, sound reveals the hidden architecture of the planet. Scientists have used it to detect earthquakes, track migrating animals, and even monitor climate change through variations in temperature that alter the speed of sound underwater. Each discovery is another reminder that the ocean is not static. It's alive, restless, constantly speaking in a language we're still learning to understand. But that language is fragile. The deeper we listen, the more we realize how easily it can be drowned out. Just as light pollution hides the stars, noise pollution hides the natural soundscape of the sea. In losing that, we lose a form of knowledge. The trench is not just a place of darkness, it's a place of delicate balance. where even the faintest sound carries meaning. If you could somehow sit at the bottom of the trench, without a submersible, without the interference of machines, you wouldn't hear silence. You'd feel it. You'd feel the slow vibration of the Earth's crust beneath you, the distant tremor of volcanic vents, the tiny movements of unseen life around you. It would be sound without sound, pressure without direction, a reminder that perception is not the same as reality. That's the essence of this world without sound. It exists fully, constantly, but beyond the range of our senses. We reach for it with microphones and sonar, with graphs and frequencies, but we never quite touch it. The ocean keeps its voice just out of reach, letting us hear enough to stay curious, but never enough to feel complete. And maybe that's fitting. Maybe the deepest part of our planet should remain a place where hearing fails, where silence becomes a form of knowledge. Because in that silence we confront not just the limits of our machines, but the limits of ourselves. Every time we descend into the deep, we're reminded that technology doesn't conquer nature, it negotiates with it. Pressure is not a problem that can be solved once and for all. It's a constant presence, unrelenting and precise. The deeper we go, the smaller our margin for error becomes, until exploration feels less like progress and more like patience disguised as engineering. Every success at those depths is temporary, fragile and hard-won. Every failure, absolute. Pressure shapes everything we send down there. The design, the materials, the mission itself. You can't improvise in the abyss. You have to plan for every outcome, imagine every failure, and accept that the ocean will still surprise you. It's not just the crushing force that makes it difficult, it's the unpredictability of it. The deeper you go, the more water changes its own rules. Temperature, salinity, and density shift constantly, creating invisible layers that can distort sonar, alter buoyancy, or interfere with communication. No computer model can capture it perfectly. The ocean doesn't care about precision. It operates on its own physics. Even the strongest materials reveal their limits. Steel, titanium, and carbon composites. Each has a point where the molecular structure begins to yield. Engineers test them in laboratories, placing samples into pressure chambers that simulate thousands of atmospheres. They listen for the faint pop that signals failure, measure how long the material holds before it gives. Every experiment adds a line to the margin of possibility. But theory is one thing, the deep sea is another. In real conditions, under real pressure, things behave differently. Seals expand, cables stiffen, joints shift by microns, and those microns matter. That's why every submersible, every probe is built like a paradox. It must be light enough to move, but strong enough to resist collapse. It must carry sensitive instruments while enduring forces that could flatten a tank. It must operate in complete darkness, with no external communication beyond a delayed acoustic signal that might not return at all. Each dive is a test not just of technology, but of humility. We're asking machines to survive in a place where even atoms behave differently. The deeper the ambition, the more fragile it becomes. We imagine exploration as triumph, flags planted, boundaries crossed. But at the bottom of the ocean, success is quieter. It's a signal returning intact. It's a camera that still functions. It's a sample container that seals properly. Those are the victories that matter. There are no crowds, no celebrations, only quiet relief when the vessel surfaces, and the engineers confirm that everything worked as it should. But nothing about deep-sea technology lasts forever. The ocean consumes everything eventually. corrosion, pressure fatigue, and microfractures all conspire to undo what we build. Even the most advanced alloys begin to degrade after repeated exposure. Electrical systems corrode under saltwater vapors, seals dry out, lenses fog. The ocean is patient, and patience is the one force no human invention has ever outlasted. That's why maintenance becomes almost philosophical. Engineers know that they can only slow the inevitable, never stop it. They spend months refurbishing machines between dives, testing connections, replacing components, re-greasing joints that will soon be stiff again. Every expedition is a cycle of repair and repetition. You prepare, you descend, you endure, you return, you rebuild. The pattern is endless, and that repetition is part of what makes deep-sea exploration both beautiful and exhausting. It's also expensive. Every minute of operation costs thousands of dollars. Every launch carries risk. The ocean doesn't offer guarantees. If something fails at depth, it's lost forever. You can't send divers to fix it, can't pull it back manually. The pressure makes rescue impossible, so you calculate the risks, insure the equipment, and hope for the best. That tension between hope and realism defines the culture of deep-sea research. Optimism builds machines. Realism keeps them running. Technology has improved immensely since the days of the Trieste, but even now our tools are limited. Modern submersibles use syntactic foams that don't crush under pressure, pressure housings made of titanium and ceramic composites, and control systems that can function autonomously when communication cuts off. But even with all of that, the average mission to the bottom of the trench lasts only a few hours. We can't linger. We visit briefly, then retreat. The abyss doesn't allow permanence. It's tempting to imagine that with enough innovation, we could build something that stays, an automated observatory on the seafloor, sending back continuous data. And we have tried. There are prototypes, pressure-tolerant modules, autonomous vehicles designed to operate for months without surfacing, powered by batteries that recharge through motion or heat differentials. But so far, none have endured long in the trench. The forces are too complex, the environment too harsh. Electronics fail, housings deform, sediment buries sensors. The ocean has its own version of entropy. Pressure changes how even time feels. When an ROV descends, the minutes stretch. Every command takes longer to execute because of signal delay. Every motion must be slow, deliberate. The machine moves at a crawl, careful not to stir up sediment that could obscure its cameras. Its exploration measured in centimeters per second, in patience rather than speed. Engineers and pilots on the surface sit in silence, staring at monitors, watching images flicker through the static. They speak in short, precise phrases, each word measured. There's no room for error, and no way to hurry the process. Down there, impatience is a form of failure. The irony of pressure is that it exposes fragility, not just in materials, but in people. The more complex the technology, the more dependent it becomes on cooperation, precision, and trust. A single loose bolt, a miscalculated tolerance, a forgotten check can undo years of work. The team dynamic becomes as critical as the machinery itself. Each person, engineer, pilot, technician, has to work as part of a whole, like components of the same system. Ego has no place in an environment that punishes even small mistakes. The fragility of ambition shows in the history of exploration itself. For every successful dive, there are countless failed attempts, missions cut short by leaks, instruments crushed, signals lost. Sometimes the failures teach more than the triumphs. Each setback forces new thinking, new design, new humility. Exploration isn't a straight line upward. It's a spiral, circling around the same challenges again and again, each time a little wiser, a little more patient. There's a quiet parallel between pressure in the physical sense and pressure in the human one. Both can shape, compress, and break. The deeper we go, the more that metaphor becomes literal. The people who work in this field learn to manage that tension. They accept that perfection is impossible, that failure is part of progress. In a way, that's what keeps them grounded. Pressure defines not just their machines, but their mindset. It teaches restraint, attention, endurance. It's also what keeps exploration honest. The ocean doesn't care about ambition, but it rewards respect. The more you push, the more you must listen. Engineers talk about listening to the material, understanding how metal behaves, how pressure reacts, how failure begins. It's not poetic, it's practical. You can hear the warning signs if you pay attention. The faint creak before deformation, the subtle drop in current before a short circuit. The people who survive in this field are those who treat the ocean not as an obstacle, but as a collaborator. Some of the most significant innovations in deep-sea exploration have come from failure. The implosion of early submersibles taught us how to build better hulls. The loss of probes led to advances in autonomous recovery. Even simple mechanical issues, a jammed manipulator, a corroded connector, have inspired new materials and designs that later found uses outside the ocean, in medicine, aerospace, and energy. The abyss, in that sense, is a teacher. It gives lessons in resilience to anyone willing to fail intelligently. But there's another kind of fragility that's harder to measure, the emotional one. The deeper the dives, the longer the missions, the greater the risk of burnout. The preparation cycles, the uncertainty, the endless repairs take a toll. Scientists spend months waiting for funding, years designing instruments that might break in an instant. They live with that knowledge constantly. Each successful dive brings satisfaction, but never closure. The ocean never feels finished. There's always another question, another problem, another reason to start over. That cycle creates a quiet kind of obsession. Some researchers describe feeling pulled toward the deep, as though the trench itself exerts a gravitational attraction. It's not thrill-seeking, it's the opposite. It's the calm certainty that something meaningful lies just beyond reach. The pursuit becomes its own reward. Success doesn't end the curiosity, it amplifies it. Each piece of data, each image from the abyss, deepens the mystery instead of solving it. That's the fragile beauty of ambition at these depths. It exists entirely on trust in design, in teamwork, in the idea that exploration matters even if it never ends. The ocean doesn't hand out final answers, only glimpses. Those glimpses sustain entire careers. People dedicate decades to studying a single trench, a single vent, a single species of microorganism that thrives in conditions we once thought impossible. That persistence isn't just scientific, it's human. It's what happens when curiosity outweighs fear. Technology makes it possible, but it's ambition that keeps it alive. The difference is that technology can be measured, but ambition can't. It grows quietly in the background, reshaping expectations. The first explorers of the trench couldn't have imagined the machines we use now, autonomous drones that navigate with artificial intelligence, sensors that measure pressure down to microbars, materials that self-heal microscopic cracks, and yet, even with all that, the distance between us and the bottom hasn't changed much. The journey still takes hours. The time spent there is still brief. The ocean remains the same. That constancy is humbling. We keep building stronger, smarter machines, but the environment we send them into doesn't evolve. It waits. It doesn't resist us. It simply exists at a scale beyond adaptation. Our progress is measured not in conquest, but in coexistence. Pressure doesn't care how advanced we become. It simply reminds us of proportion. That's what makes deep-sea exploration so different from space exploration. In space, the challenge is distance and emptiness. In the ocean, it's proximity and presence. The environment isn't far away. It's all around, pushing inward from every direction. Every dive is a confrontation with the most fundamental question of technology. Can something built by fragile beings survive a place that doesn't care about fragility? So far the answer has been yes, but only barely. Every time a submersible descends, it carries that fragile ambition like breath inside a bubble. The entire system, mechanical, electrical, human, depends on maintaining equilibrium. Too much pressure inside or out and it collapses. The success of the dive is measured not by what we find, but by the fact that we return at all. That's the quiet victory at the heart of exploration. And when the machines surface again, dripping with salt, coated in sediment, their lights flickering from the cold, they look less like instruments and more like survivors. They are proof that even in the face of overwhelming force, persistence works. Not because it wins, but because it endures. That endurance is fragile, but it's enough. The ocean may always have the final word, but as long as we keep sending our fragile ambitions into its depths, that word will never be silence. In the dark where no light reaches, life continues, not as an echo of the surface, but as something else entirely. When people imagine the deep ocean, they often think of emptiness, a cold desert with nothing moving but slow drifts of water. But that assumption comes from what we can't see, not what is absent. The abyss isn't empty, it's full, just in a way that doesn't resemble our world. What looks like stillness is activity stretched across impossible timescales. What appears lifeless is adaptation refined through millions of years of quiet persistence. The first time scientists brought back living organisms from the trench, the surprise wasn't that something existed there. It was how familiar it felt and how strange at once. Small amphipods, shrimp-like crustaceans, wriggling and pale, their bodies transparent, their movements precise. They were feeding on particles that had drifted down from the surface, fragments of what had once been plankton, fish, or plants. They didn't need sunlight. Their world is built on patience. They eat what the rest of life forgets. Every layer of the ocean adds new rules to life. In shallow water, organisms compete for space, light, and food. In the deep sea, competition gives way to endurance. The creatures here survive not by abundance but by efficiency. Every movement is calculated. Every organ, every system is tuned to make use of as little energy as possible. It's not survival of the fittest in the way we imagine it. It's survival of the quietest, the most patient, the least wasteful. Even the bodies of these creatures reveal that logic. Their skeletons, when they have them, are flexible rather than rigid. Their muscles are soft, their forms fluid. Pressure isn't something they resist, it's something they inhabit. Where a human body would collapse, theirs remains unchanged. The deep ocean doesn't forgive inflexibility. To live there is to become part of the pressure, to let it pass through you rather than fight against it. Some of the life forms in the trench are unlike anything else on the planet. There are snailfish that live deeper than any other vertebrate, their skin gelatinous, their bones reduced to cartilage. There are amphipods that can tolerate pressures that would crush submarines, their cells stabilized by unique molecules that prevent collapse. There are microorganisms living inside the sediment where no light, oxygen or warmth exists, feeding on traces of chemicals leaking from the Earth's crust. To them, life is not fragile, it's inevitable. In 2019, researchers found microbes living in the mud of the Challenger Deep that had been there for thousands of years, possibly longer. When brought to the surface, they began to reproduce immediately as if nothing had changed. It was a quiet revelation. Even in the most extreme isolation, life doesn't simply endure. It waits. Those microbes are part of a vast invisible system that connects the trench to the rest of the planet. They process carbon, recycle nutrients, and maintain chemical balances that reach up through the water column. In ways we barely understand, they're part of the same life cycle that includes us. That connection is easy to forget. When we talk about the deep, we often imagine it as separate, as if it belongs to another planet. But the truth is that the deep ocean affects the surface in every moment. The water that sinks to the bottom eventually rises again, carrying with it the memory of temperature, chemistry, and life. The trench isn't just a destination, it's a passage, part of a global circulation that shapes the entire biosphere. Every breath of wind above the sea, every current of air that crosses a continent is linked to that hidden movement below. The abyss is the slow heartbeat of the planet. The organisms that live there are expressions of that heartbeat. Many produce their own light, not for beauty but for necessity. In total darkness, bioluminescence becomes a universal tool. Some species use it to lure prey, others to find mates, others to confuse predators. There are fish with lights dangling from their heads, jellyfish that flash to startle attackers, bacteria that glow from within their hosts. Each glow is a signal, but also a gamble. In a world where food is scarce, light can mean survival or exposure. Scientists who have witnessed these displays describe them as surreal, not because they are bright, but because they appear out of nothing. One moment, complete blackness. The next, a pulse of blue, a spiral of green, a drifting constellation of points that fade before you can focus on them. It's not a performance. It's communication happening in a language we barely grasp. Each flash has a rhythm, a frequency, a pattern of intensity. It's not random. It's speech in light. Even at the deepest levels of the trench, where pressure reaches beyond what most life can tolerate, there are still traces of activity. Bacteria thrive inside the sediment, feeding on chemicals released by reactions between water and rock. Some of these bacteria form symbiotic relationships with other organisms, small worms, crustaceans, even larger creatures, that rely on them to process nutrients. Life in the deep isn't isolated. It's woven together in invisible partnerships, each species sustaining another. When a large organism dies near the surface, its body begins a slow descent, drifting downward through the water column. Scientists call it marine snow when it's small debris. But when it's something large, like a whale, it becomes what they call a whale fall. Over the course of weeks or months, that single carcass becomes an entire ecosystem. Hagfish, amphipods, and worms gather first, stripping the flesh. Then bacteria colonize the bones, breaking them down to release nutrients. The cycle continues for years. In a place where food is so rare, one whale can feed thousands. Death above sustains life below. That rhythm of decay and renewal defines the abyss. It's not a place of constant activity, but of steady balance. Everything moves slower, lasts longer, and exists in proportion to the energy available. Even reproduction follows that pattern. Some species lay eggs that take months to hatch, their embryos developing slowly in the cold. Others reproduce only once in their lifetimes, ensuring that their offspring have the best possible chance to survive. Nothing in the deep happens quickly. Time itself feels stretched, diluted, quiet. When explorers record footage of these creatures, what stands out isn't their strangeness but their precision. A snailfish hovering inches above the seafloor, barely moving its fins. A shrimp sifting through sediment with delicate patience. A jellyfish pulsing rhythmically, conserving energy with every motion. There's no chaos, no waste. It's life reduced to its essence. Existence without distraction. That minimalism might be the most alien thing about the deep. On the surface, we associate life with motion, noise, and colour. In the trench, life is almost invisible, a presence more than an image. It doesn't announce itself. It simply persists. The simplicity is deceptive, though. These organisms are the product of immense evolutionary complexity. Their enzymes function under pressure that would destroy ours. Their cells maintain structure through chemical bonds we barely understand. Their metabolisms operate at temperatures close to freezing, with no access to sunlight. They've solved problems that human engineering still struggles with every day, and yet, despite all that sophistication, they exist quietly, without altering their world. They don't build, they don't expand, they don't consume more than they need. They live in balance because there's no alternative. In that sense, the abyss offers an unintentional lesson in restraint. It shows that survival doesn't require dominance, only adaptation. The creatures of the deep are masters of balance in a way humanity has never been. The more scientists study them, the more questions emerge. How do their bodies maintain fluid balance under such pressure? How do their proteins remain stable? How do their cells repair damage without oxygen? Each answer opens another layer of mystery. What we know now is a fragment of what exists. The vast majority of deep-sea species remain undiscovered, unrecorded, unnamed. Every dive reveals something new, sometimes just a glimpse, a strange fin, a translucent shell, a flicker of movement that vanishes before the camera can focus. There's a strange comfort in that. In an age where so much feels mapped, categorized, and known, the ocean remains a reminder that the unknown is still vast. It's not hidden out of reach. It's just deeper than we can easily go. That mystery keeps exploration alive, not as a search for control, but as an act of curiosity. But it's also fragile. The deeper we study the trench, the more we discover traces of ourselves there. Plastic fibres, microbeads, chemical residues. Even in the most remote depths, human influence has arrived. Amphipods collected from the Challenger Deep have been found with particles of plastic in their bodies. The chemicals from industrial waste have settled in the sediment. We can't live there, but our impact does. The paradox is painful. Our exploration, meant to expand understanding, also reveals how far our pollution has spread. That discovery has changed how many scientists think about their work. The trench is no longer just a place of wonder. It's also a mirror. It reflects both the endurance of life and the reach of our mistakes. Every specimen brought to the surface tells two stories: the story of adaptation and the story of intrusion. The creatures that survive there now do so in an environment subtly altered by us, though we barely understand the consequences. Still, life continues. It always does. The deep is resilient in ways that defy imagination. Some bacteria can digest plastic, breaking it into harmless compounds. Others have evolved to thrive on pollutants as food. It's not redemption, it's adaptation again, the same principle that governs everything below. The ocean doesn't moralize, it adjusts. It absorbs change, incorporates it, and continues. In that, there's a kind of quiet hope. If life can persist there, in cold, pressure, and darkness, then it can persist anywhere. It doesn't need perfection. It needs time. The abyss shows that endurance is not the absence of struggle, but the acceptance of it. The creatures living miles below the surface aren't fragile. They're precise, efficient, inevitable. When you imagine them now, try not to think of monsters or aliens, but of perfection shaped by necessity. Each one is the answer to a question the surface never had to ask. How do you exist without light? How do you eat without abundance? How do you live where nothing seems possible? Their answers aren't spoken, but they're there, in every pulse of light, every measured movement, every quiet heartbeat beneath the weight of the world. They don't know we exist, and they don't need to, but in studying them, we catch a glimpse of what life really means when stripped of everything unnecessary. Not comfort, not dominance, not speed, just presence. And somewhere far above them, ships cross the surface, satellites pass overhead, storms gather and fade. None of it matters down there. The trench continues in silence, its creatures moving slowly through an endless night, sustained by the faint trace of everything that falls from above. Life in the abyss is not about conquest. It's about continuity. It's not a story of beginnings or endings. It's what happens in between, in the long, quiet persistence that keeps the planet alive. The deeper we study the ocean, the more we realize that knowledge itself behaves like pressure. The more we have, the more it compresses us toward the truth that we still understand almost nothing. The trench is not mysterious because it hides things. It's mysterious because it reveals so little even when we look straight at it. Our instruments record, our sensors detect, our cameras illuminate small circles of visibility, but beyond those faint pools of light stretches a vastness that refuses to be measured. Every image is a fragment, every sample a whisper from a place that doesn't want to be summarized. Science is built on the idea that if you ask enough questions, the world will eventually make sense. But the ocean doesn't care about our sense-making. It follows its own timeline, its own slow arithmetic of change. The trench, in particular, moves at the pace of geology and chemistry, not biology. The rocks there shift by centimetres over centuries. The currents recycle nutrients over thousands of years. Human curiosity operates on a much shorter clock, and that mismatch defines the limits of what we can ever know. The equipment we use to study the deep is a marvel of engineering, but it also defines the boundaries of discovery. Cameras can only capture what their light reaches. Sonar can only map what reflects sound. Sensors can only detect what they're designed to measure. The trench operates far beyond those parameters. There are movements too subtle, organisms too small, processes too slow for our instruments to register. Even time itself feels distorted there. A bacterial colony that doubles every few years instead of hours or days might seem inactive to us, but within its own frame of reference, it's thriving. Our impatience becomes blindness. Every expedition begins with hope and ends with data, numbers, graphs, readings, samples. Those results are analysed, cross-referenced, modelled and archived. They become part of the expanding body of scientific knowledge, but that body is always incomplete. The deep ocean is too vast to be captured by any data set. What we know is a series of outlines drawn from limited contact. Between those outlines are spaces filled with uncertainty. Scientists are honest about that. They don't claim certainty, they claim approximation. That honesty is part of what makes deep-sea research different from most other sciences. It's a field built on acknowledging limits. You can't run controlled experiments easily when the subject of study lies under 11 kilometers of water. You can't reproduce its conditions in a lab without extraordinary expense. You can't even guarantee that what you find on one dive will be there on the next. The environment changes constantly. Currents shift, sediments move, creatures migrate. The ocean refuses to sit still long enough to be neatly categorized. There's a quiet humility in that. In an age when information seems infinite, the trench reminds us that ignorance still exists in abundance. It's not failure, it's part of the landscape. Some scientists describe their work not as discovery, but as negotiation. A conversation with the unknown in which most of the talking is done by silence. The data we collect is like hearing half a sentence in a storm and trying to guess the rest. Even our most advanced mapping of the seafloor is incomplete. Satellites can measure gravitational variations caused by underwater mountains and valleys, giving us a rough idea of what lies beneath, but the resolution is limited. It's like seeing the outline of a city from space without being able to distinguish a single street. Only direct sonar mapping can fill in the details, and that takes time, years of slow scanning piece by piece. Less than a quarter of the global seafloor has been mapped at high resolution. The trench itself, one of the most studied locations, remains mostly uncharted in fine detail. Beneath every known coordinate lies uncertainty. The limits extend beyond technology. There are also economic and logistical barriers. Deep-sea exploration costs millions of dollars per mission. Each dive involves ships, crews, equipment, and months of preparation. The weather must cooperate. The ocean must stay calm. The machinery must function perfectly. A single malfunction can end an entire expedition. The ocean doesn't negotiate with schedules. It works on its own rhythm, and sometimes that rhythm says no. Then there's the human limit, the one we rarely admit. Curiosity may be infinite, but endurance isn't. The scientists and engineers who dedicate their lives to studying the deep often work for decades, knowing that the questions they ask may never be answered. Some retire before the data from their missions is fully processed. Others spend years refining a single instrument that will take one measurement before failing. It's a slow, patient kind of pursuit, measured in lifetimes rather than results. That patience creates a unique kind of wisdom. The people who study the trench don't talk about conquering it. They talk about respecting it. They learn to listen to what it doesn't say, to see meaning in the gaps between measurements. In that sense, the limits of knowing aren't barriers, they're invitations. They remind us that understanding isn't a destination but a process. Still, the desire to see further remains. Every generation of researchers builds on the work of those before, designing more sophisticated tools, imagining deeper dives, more autonomous systems. Artificial intelligence now processes sonar data faster than any human team could. New materials allow sensors to function under greater pressure, But even as we improve the tools, the mystery deepens. The more clearly we see, the more complex the picture becomes. Every answer raises 10 new questions. That's the paradox of knowledge. It expands the unknown instead of shrinking it. We've seen this before in other frontiers. Space, the human brain, quantum physics. Each promised answers and delivered instead an expanded sense of scale. The trench fits into that pattern perfectly. It's not just a geographical location, but a metaphor for the edges of human comprehension. It's a reminder that knowing everything is not the same as understanding everything. The data we collect might one day describe every chemical and biological process in the deep, but that won't capture what it means to exist there, what it feels like to be part of that pressure and darkness. Knowledge can describe, but it can't inhabit. That realization changes the purpose of exploration. It shifts it from domination to dialogue. The point isn't to extract all the secrets from the ocean, but to learn how to ask better questions. That shift has already begun in the way oceanography is conducted. Instead of massive one-time expeditions, researchers now focus on long-term monitoring, on observing rather than intervening. They deploy instruments that stay for months, even years, quietly recording changes. The goal isn't discovery in the dramatic sense, it's observation without disturbance. The ocean reveals itself slowly, and only when approached with patience. Even then, some things may remain unknowable. There are phenomena that defy explanation, sounds with no source, currents with no cause, organisms that vanish before they can be studied. It's not because we're not clever enough, but because the systems are too complex. The trench is a product of geology, chemistry, biology, and time interacting on scales far beyond our own. Trying to understand it fully is like trying to hear an entire symphony through a single note. We can sense the structure, but never the whole. That might sound frustrating, but it's also liberating. It means there will always be something left to learn. Mystery is not an obstacle to science, it's its engine. Without it, curiosity would die. The trench ensures that curiosity remains alive. Its silence, its pressure, its unending complexity. All of it serves as a reminder that the world still holds secrets that no algorithm can decode. There's also something deeply human in admitting those limits. For centuries, exploration was driven by the illusion of mastery, the belief that the world existed to be charted, categorized, and controlled. The trench resists that narrative. It can be mapped, measured, and visited, but not possessed. It's not ours to own or to finish understanding. It exists independently of us, and that independence humbles even the most accomplished scientist. Standing on the deck of a research ship after a dive, watching the ocean surface ripple back into stillness, the feeling isn't triumph, it's quiet awe. The realization that beneath that calm lies a world that has existed for millions of years without needing us. The instruments are hauled up, the data stored, the samples sealed, and yet the most important thing brought back is often not material. It's perspective. That perspective can't be graphed or recorded. It's the recognition that knowledge isn't just about collecting facts. It's about understanding our place in what we study. The more we learn about the trench, the clearer it becomes that we are temporary observers in a system that doesn't require our presence. The limits of knowing are not failures. They are the shape of our relationship with the unknown. There's a quiet irony to how we talk about exploration as progress. Each new expedition, each new piece of technology is described as breaking barriers. But the deeper truth is that exploration isn't about breaking anything. It's about returning again and again to the same mysteries and finding new ways to look at them. The trench doesn't change. We do. The instruments improve, the data grows richer, but the essence remains untouched. The ocean's silence still says more than all our senses combined. It's easy to think of the unknown as a void to be filled, but maybe it's better understood as a space that gives meaning to what we already know. Without it, knowledge becomes static. The trench keeps that balance alive. It reminds us that certainty is a kind of blindness, that wonder depends on limits. If you could stand at the bottom of the trench and look around, you would see almost nothing, and yet that nothing would contain everything we've ever wanted to understand. How life adapts, how matter behaves, how existence persists under impossible conditions. The limits of knowing aren't walls, they're horizons. They move as we move, always slightly ahead, always inviting. That's why, even after centuries of exploration, the deep still calls to us. Not because we expect to master it, but because it mirrors the part of ourselves that keeps asking why. The unknown is not the enemy of understanding, it's its companion. Without it, the search would end. And perhaps that's the quiet truth of the trench. It doesn't need to be solved. It just needs to be known as a reminder that even in a world mapped by satellites and measured by algorithms, there are still depths where knowledge bends, where certainty dissolves, and where the act of wondering is enough. Sometimes, when people return from long ocean expeditions, they talk less about what they discovered and more about what they began to notice in themselves. The ocean changes your sense of proportion. It's not just the vastness, though. That alone is enough to reorder priorities. It's the way the ocean reflects everything back at you without judgment. The trench, especially, doesn't care who you are, how advanced your tools are, or what you hope to find. It shows you what you bring with you, and nothing more. That's why so many explorers describe it as humbling rather than triumphant. They descend to study the world and return realizing they've been studying perspective itself. When we look into the deep, what we're really seeing is the measure of our curiosity and the boundaries of our endurance. The ocean becomes a kind of mirror, one that doesn't flatter but clarifies. It reveals what we value, what we fear, and how far we're willing to go to satisfy the simple, stubborn urge to know. That reflection can be uncomfortable. It shows the tension between wonder and control, between reverence and intrusion. It asks questions without speaking. Why do you need to see this? What are you hoping to prove? What will you do with what you find? For most people, the surface of the sea is enough. They see blue water, waves, sunlight, a place to swim or sail or fish. It's beautiful, calming, vast. But for those who look deeper, the ocean becomes a reminder that beauty and danger, creation and destruction, always coexist. Every wave that breaks carries a memory of the moon's pull, of wind crossing thousands of miles, of unseen currents below. The trench amplifies that duality. It's both part of the same system and completely apart from it, a contradiction that feels familiar when you think about it long enough. Humans have always used water as metaphor. It's where we project our emotions, our fears, our ideas about purity, chaos, transformation. When ancient myths described the sea, they weren't just describing geography. They were describing the unknown parts of themselves. The abyss was never only a physical depth. It was a symbol for what can't be measured or controlled. Thousands of years later, we still use it the same way. We talk about diving deep, surfacing, drifting, drowning, as if the language of water is the only way to describe emotion honestly. Maybe that's why the ocean feels familiar even to those who've never seen it up close. It's built into how we understand ourselves. But standing on the deck of a research vessel, Looking down into thousands of meters of darkness, that metaphor becomes literal. You see your own reflection on the water's surface, faint and distorted, floating above a depth you can't imagine. For a second, the separation between observer and subject disappears. The mind does what it always does in moments like that. It reaches for meaning. You think about everything that lives down there, about the age of the water beneath you, about how that same water has circulated through countless forms of life before returning here. It's impossible not to see yourself as part of it. The ocean doesn't respond, but it doesn't need to. Its silence is an answer in itself. It tells you that perspective doesn't come from conquering or categorizing, but from recognizing scale. The trench, in that sense, is the most honest mirror we have. It shows how small we are without making smallness feel like failure. It reminds us that insignificance and belonging are not opposites. You can be tiny and still part of everything. That realization changes how you think about exploration. It stops being about heroism and starts being about connection. Every measurement, every dive, every image captured in the dark becomes an act of dialogue. You're not extracting knowledge, you're participating in it. The trench doesn't yield secrets to those who demand them. It allows glimpses to those who approach with patience. That patience becomes its own reward and its own kind of reflection. It's easy to forget that most of the ocean's processes happen without us. Currents move heat around the planet, regulating climates. Plankton absorb carbon, releasing oxygen into the air. The deep stores history in layers of sediment, recording every eruption, every extinction, every shift in temperature. The ocean remembers what the land forgets. When we study it, we're not just looking at a natural system, we're reading the diary of the planet. And like any diary, it reflects not only the events but the tone of the writer. In this case, the writer is Earth itself, steady, slow, and indifferent. But that indifference isn't cold, it's simply balance. The trench doesn't need attention or interpretation. It exists perfectly as it is, operating on scales that make our urgency seem small. To see that clearly is to confront a different kind of truth. The idea that progress, as we define it, might not be universal. The ocean doesn't progress, it cycles. It changes and returns, erases and creates, without ever moving toward an end. That's the mirror it holds up, a reflection of continuity without destination. For humans, that's difficult to accept. We're built around beginnings and endings, around goals and achievements. The deep doesn't offer that. It has no finality, no obvious purpose. It exists, and that's enough. The longer you think about that, the more you realize how much of our anxiety comes from the inability to be still. The trench teaches stillness, not as passivity, but as a form of strength. Nothing down there resists the environment. Everything adapts to it. Pressure doesn't break life there. It defines it. In that way, the ocean mirrors resilience, not in defiance, but in surrender. There's something deeply human about needing that kind of reflection now. The surface world moves faster than it ever has. Data flows endlessly, attention scatters, everything accelerates. The trench, by contrast, moves in geological time. A current that forms there might take 1,000 years to complete its circuit. A rock slide that shifts a few meters today might define the landscape for millennia. The creatures living there evolve slowly, their changes invisible on human scales. That slowness feels almost sacred when compared to the speed above. It's a reminder that not all change needs to be visible to be real. When researchers watch footage from deep cameras, What strikes them most isn't what happens, but how it happens. A shrimp moves an inch, a cloud of sediment drifts lazily. A small fish hovers motionless for minutes at a time. Nothing rushes. Time seems to stretch until it stops feeling like time at all. You start to see patterns in stillness. The rhythm of motion without hurry, existence without performance. And in those moments, something in the observer changes too. You stop waiting for action and start noticing presence. The reflection shifts inward. That inward reflection has always been part of why humans explore. We think we're searching for new worlds, but often we're trying to understand this one, and ourselves within it. The ocean is honest in what it reveals. It doesn't show beauty for its own sake or danger for drama. It shows continuity. The same water that laps against a beach somewhere in the Pacific is the water that once filled the trench, that once evaporated into clouds, that once fell as rain onto distant land. It's a system without hierarchy, where everything is connected by movement rather than dominance. That's the mirror's message: connection without control. Sometimes, when scientists describe their findings, they use words that sound almost philosophical. They talk about equilibrium, feedback, resilience. These aren't just scientific terms, they're ways of describing coexistence. The trench forces that language on us because there's no other way to make sense of it. You can't describe it through conquest or profit. You can only describe it through relationship. And that relationship extends beyond science. Every culture that has lived near the sea has found meaning in it. Some see it as sacred, some as dangerous, some as nurturing, some as unknowable. The common thread is reverence. The trench deepens that feeling. It takes what's abstract, the idea of the unknown, and makes it literal. It gives us a place to project wonder without the illusion of ownership. There's a quiet grace in that. The ocean doesn't need to reflect our values to be valuable. Its worth doesn't depend on what we find there. The mirror works even when we look away. Its reflection continues whether we're paying attention or not. That constancy is rare, and it's something we depend on more than we realize. The ocean absorbs our heat, our carbon, our mistakes. It stabilizes a planet that has become unpredictable in every other way. And in doing so, it reflects not only who we are, but what we've done. That's the harder side of the mirror. It shows the cost of curiosity and consumption alike. When scientists find plastic in the bodies of amphipods or chemical traces in sediment cores, it's not the ocean accusing us. It's simply showing us what's true. The mirror doesn't distort, it reveals. The reflection isn't cruel, it's complete. Seeing it clearly is the first step toward understanding our place in the story we've written across the planet. But the mirror also shows hope, in the way life persists despite everything. The deep remains alive, complex, resilient. It doesn't erase our impact, but it absorbs it, transforms it, and continues. It reflects back a model of endurance that we might learn from if we were willing to listen. The trench doesn't resist change, it accommodates it. That ability to adjust, to absorb, to continue, might be the most powerful reflection of all. What's striking about looking into the ocean long enough is how it strips away everything unnecessary. The noise, the competition, the urgency, all of it fades when faced with something so immense and self-contained. What's left is scale and simplicity. It makes the things that once seemed large, ambition, fear, even mortality, feel smaller, but not meaningless, just properly sized. The mirror doesn't diminish us, it puts us in context. When explorers talk about the moment they first saw the bottom of the trench, they rarely mention excitement. They talk about quiet. The lights from their submersibles illuminated a patch of sediment, a few small creatures, and nothing else. It wasn't dramatic or cinematic. It was still. And in that stillness, many describe feeling connected, not to discovery or achievement, but to the fact of existence itself. The mirror was complete. There's no grand revelation waiting at the bottom, no hidden civilization, no treasure. The value of the journey is the reflection it offers. The ocean doesn't need to tell us new stories. It reminds us to listen to the old ones, the stories of balance, patience, and presence. It shows that survival isn't about conquering the unknown, but about coexisting with it. And when the explorers return, when the ship turns back toward land and the horizon reappears, that reflection doesn't fade. It lingers quietly, reshaping how they see everything else. The sky, the noise, the movement of cities. The ocean remains in them, not as memory but as measure. The mirror has done its work. Above the trench, the world continues with its noise and urgency, but below, the same currents move as they always have. The water carries history without comment, reflecting both what we've done and what we might still learn. And in that reflection lies the truth we keep rediscovering. The deeper we look into the ocean, the more clearly we see ourselves. When we talk about the deep, it's easy to forget that we carry part of it inside us. The salt in our blood, the water in our cells, the rhythm of our hearts, they're all echoes of the ocean's history. Every living thing on land is descended from something that once drifted in the sea. We may have left the water millions of years ago, but it never really left us. It still shapes how we live, how we think, how we dream. Maybe that's why we keep returning to it, in person or in thought. We're not just exploring something foreign, we're remembering something familiar. The idea of the ocean as distant is convenient. It allows us to treat it like a separate world, an environment to visit, to study, to protect. But the truth is that it isn't separate at all. Every raindrop, every breath, every meal connects us back to it. The water cycle that fills our rivers and feeds our fields starts and ends with the sea. The oxygen in the air we breathe comes largely from microscopic life in its surface layers. Even our climate depends on the slow pulse of deep currents that rise and fall over centuries. We live because the ocean breathes. That connection makes the trench more than a curiosity. It makes it a mirror of our interior world. When you think about it long enough, the parallels become unavoidable. The surface of the mind is bright and active, full of movement and distraction. But beneath that is depth, silent, cold, pressurized, unknown. Most of what makes us who we are lies there, hidden, shaping what happens above, the same way the deep sea shapes the surface without ever being seen. It's not an easy thing to face, that inner depth. We prefer the visible, the measurable, the things we can explain. But like the ocean, the human mind resists full understanding. You can map parts of it, name its processes, describe its chemistry, but its essence, what it feels like to exist within it, remains uncharted. And maybe that's the point. Knowing everything would mean losing the mystery that gives meaning to knowing at all. The deep within us, like the deep beneath us, must stay partly in shadow to stay alive. When explorers talk about descending into the trench, they describe a narrowing of focus. Everything extraneous falls away. You're aware of breathing, of the hum of machinery, of pressure pressing from all sides. It's not claustrophobia exactly, it's presence. In those moments, nothing exists except the space you occupy and the weight surrounding it. That sensation, though extreme, is familiar in smaller ways. We feel it in silence, in solitude, in those moments when the noise of life fades and we're left with only ourselves. The same awareness that terrifies at first can also calm. The same darkness that hides can also protect. The ocean teaches both lessons at once. That's the paradox that keeps pulling people back. The deeper we look into the trench, the more it resembles consciousness itself, an environment that can't be fully observed from within. We send instruments into the ocean to study it, the way we use memory, language, and introspection to study the mind. In both cases, what we get back are reflections, measurements, images, fragments of understanding that point towards something larger, but never capture it completely. The more we learn, the more we realize how much is beyond reach. The trench reminds us that limits aren't barriers but structures. Without them, curiosity would have nowhere to push against. The same applies to our inner depths. The unknown inside us, the parts we can't name or predict, is what gives us empathy, creativity, longing and wonder. The same pressure that shapes life in the deep shapes our resilience on land. The same silence that fills the trench is the silence we return to when we think, when we rest, when we grieve. The deep within us and the deep below us are reflections of the same pattern. Persistence through pressure. Sometimes, when you listen to recordings from the ocean floor, you can hear what sounds like a heartbeat, a rhythmic pulse of seismic activity, slow and steady. It's not alive in the biological sense, but it feels alive. It feels like the planet itself breathing. That sound, faint and low, is a reminder that the earth isn't static. It's moving, flexing, sighing under its own weight. And we, who evolved from it, carry that rhythm. Our pulse matches its cadence more than we realize. When you fall asleep listening to the sea, what soothes you isn't just the sound of water, it's recognition. The trench is often described as unreachable, but in truth, we reach it every time we imagine it. Every time we think about the unknown, we descend a little. The human mind doesn't need pressure chambers to visit dark places. It creates them on its own. We carry the same mixture of curiosity and fear that every explorer feels before a dive. We build our own vessels, memory, reason, imagination, to explore what lies beneath. And like the submersibles we send into the deep, those vessels are fragile but necessary. They keep us from collapsing under the weight of what we don't understand. That's why stories about the ocean resonate so deeply. They're not really about the sea. They're about survival in the face of mystery. They remind us that being small in a vast world isn't weakness, it's perspective. The trench doesn't diminish us, it situates us. It shows that scale isn't about superiority, but participation. We belong to something immense, and that belonging is enough. There's also something honest about the way the deep resists us. It's a boundary that can't be ignored or negotiated. We can reach it for moments, but we can't live there. The same is true of our inner depths. We can visit, reflect, learn, but we can't stay submerged forever. Life requires returning to the surface, to air, to light, to connection. The descent teaches perspective. The ascent gives it meaning. The two together form the rhythm of understanding. When people return from the deep, they often describe the world differently. Colours seem sharper, sounds clearer, even air feels heavier, richer. It's as though the absence of sensory input in the depths resets perception. The same thing happens after deep introspection. You come back seeing ordinary life as extraordinary. The ocean doesn't just reflect us, it recalibrates us. It slows us down long enough to notice what's been there all along. It's easy to think of exploration as a search for what's missing, but maybe it's a way of remembering what's already present. The trench doesn't hold answers we don't have. It holds reminders of what we forget. Patience, balance, continuity. The way everything connects through cycles too vast for one lifetime to see. These aren't discoveries, they're recognitions. When you look closely, even the smallest organism at the bottom of the ocean carries the same message written in its structure: endurance without defiance. That message has always been there, waiting in the dark, whispered through the pressure and the currents. The ocean doesn't speak in words, but it communicates in forms, movement, temperature, rhythm. To understand it, we don't need translation, we need attention. Listening is the hardest part, not because the ocean hides its voice, but because we've grown so used to noise that silence feels unfamiliar. But when you finally settle into it, when the internal chatter fades and the background quiet becomes whole, something shifts. The line between inside and outside blurs. The deep isn't somewhere else anymore. It's everywhere. You can feel that even on the shore, standing at the edge where land meets water. The pull of the tide, the weight of air thick with salt, the sound of waves repeating themselves without hurry. It's the same language spoken differently. The ocean doesn't need depth to remind you of what it is. The trench is just the extreme version, the part that refuses to be tamed. But the message is consistent, from the shallowest tide pool to the darkest abyss. Everything moves together, slowly, perpetually, without waste. Sometimes the most profound thing about the ocean is how indifferent it seems. It doesn't celebrate, it doesn't mourn, it doesn't demand recognition. And yet, within that indifference lies the foundation of life itself. It nurtures without intention, balances without agenda. It exists in a state we keep trying to name but can't. Something between stillness and motion, between chaos and order. When you recognize that, it changes how you see the world. You stop expecting perfection. You start noticing patterns instead. You start seeing the same calm beneath everything. The deep within us behaves the same way. It's where emotions settle, where experiences compress into memory, where meaning forms quietly under pressure. We spend most of our lives skimming the surface, talking, moving, reacting. But the shape of who we are is defined by what lies beneath. That's where resilience grows, where empathy forms, where imagination begins. Like the ocean, it doesn't need light to function. It just needs time and depth. When you close your eyes at night and everything goes still, you can almost feel it. The slow, steady pulse of that inner sea. Thoughts drift like currents. Images rise and fall like plankton. There's movement, but it's soft, contained. Sleep itself might be the closest we come to descending the trench. The surface world fades, sound becomes muffled, time loses its shape. What's left is rhythm, pressure, and memory. That's why dreams feel so vast. They follow the same physics as the ocean, infinite, layered, non-linear. We often think of darkness as absence, but in the deep it's fullness. Every molecule, every vibration, every trace of energy still exists there, woven into an invisible fabric. The same is true of silence. It's not the absence of sound, but the presence of all sounds waiting to be heard. That's what the ocean teaches, and that's what the inner deep mirrors. Beneath everything loud and temporary lies a continuity that doesn't end. If you could look at the trench from space, it would appear as a scar across the planet, a narrow wound running along the ocean floor. But that's not what it is. It's more like a breath, an opening into the Earth's slow heartbeat. It's where tectonic plates meet and move, recycling old crust into new. It's creation disguised as destruction, motion hidden as stillness. Everything about it contradicts the surface understanding of what deep means. It's not isolation, it's connection under pressure. And maybe that's what we've been trying to understand all along. That depth, whether in the ocean or in ourselves, isn't about distance or difficulty. It's about relationship between what is seen and unseen, known and unknowable, fragile and enduring. The trench isn't an endpoint. It's a reminder that every limit is a transition. The same is true of awareness, of life itself. When explorers finish their reports and return to ordinary routines, the ocean doesn't disappear from them. It lingers quietly in the back of thought, resurfacing in small moments. A glass of water, a sound of rain, the quiet of night. The awareness doesn't fade, it deepens. That's how the deep works. Once you've known it, even briefly, you can't separate from it again. You realize it's been there the whole time, both beneath your feet and within your chest. If you listen now, wherever you are, there's a rhythm underneath everything else. It's not loud, it's not even consistent, but it's there. The soft pulse of continuity that connects the breath you take to the waves that move unseen across the world. That's the same rhythm the trench holds, the same one the earth itself follows, the same one life obeys without knowing. It's not something to be studied or solved. It's something to be remembered, and maybe that's the quiet purpose of all this. To remember that we belong to something immense and ancient, that we're shaped by forces we can't see, that every mystery we look for out there already exists inside us. The deep within us is not a place of fear, it's a place of return. The water has always known that. It doesn't ask for anything, it just waits, endlessly patient, moving in cycles that outlast memory. We are made of that patience, whether we realize it or not. And though we'll never truly explore the trench, we've been carrying it with us all along. So breathe, let the noise fade, feel the weight of stillness for a moment. Somewhere, far below the surface, the deepest part of the ocean moves slowly in the dark, and somewhere inside you, the same motion continues, steady, enduring, and alive.